Hey everyone, Sean Watase here, and welcome to our Account Abstraction course. This course was designed to teach you everything you need to know about account abstraction, from what is account abstraction to how it works, to even implementing it into your Web3 applications. Account abstraction is something that truly has the power to simplify Web3 applications for mass adoption, and we'll be leveraging tools like thirdweb to learn how to easily implement these into your Web3 projects. Whether you're building a web application, a mobile app, or a game, we'll teach you all the tools that you need to know in order to implement account abstraction into your Web3 project. Now, this course was designed and broken into individual sections, each section leading into the next. And the timestamps for all these sections and each part of those sections will be down in the description below. So if you ever need to reference to a specific section, if you want to skip ahead, or if you need to go back and rewatch anything to make sure you better understand it before moving on, again, down in the description, we'll have all the timestamps you need to navigate your way through this course. Now, an overview of what we're going to be covering in this course. The first section is our introduction section, and in here, we'll be introducing things like account abstraction, what it is, how it works, and the why behind why you may want to use something like account abstraction for your Web3 project. The section after that, we'll be covering something called account factory contracts. We're going to be going over what they are and how they work. And then we'll go over a few of the account factory contracts provided by thirdweb, and we'll go through each one and how they differ from each other. In the following section, we'll start to implement account abstraction into our Web3 projects utilizing thirdweb. We'll be using something called smart wallets, and we'll be implementing them into our Web3 applications using thirdweb's Connect Wallet UI component. We'll implement this into web apps using React, into mobile apps using React Native, and we'll even show you how you can implement this into a game using Unity. We'll then cover in the next section how you can create your own custom Connect flow using some of thirdweb's tools. We'll be utilizing something called embedded wallet, which allows a user to sign in with email or social logins and use that to connect then to a smart wallet and enable smart wallet features within our application like gasless and signless transactions. And then in the next section, we will create our very own custom account factory contract, add some logic and functionality to it, and then build another Connect flow, but utilizing the custom features we added to the smart contract. And finally, we'll cover something called permissions and session keys, which is something that account abstraction allows you to accomplish when integrated into your Web3 application. So again, there is a lot to cover in this course, and we will have all the timestamps down in the description. So if you need to take a break, come back to the video, you can always find out where you left off and continue there. Now, before we get started, there are some prerequisites we want to mention before we get into this course. This course is purely about account abstraction, how it works, and how we can start implementing it into our Web3 applications. And we're not going to go over any basics or fundamentals when it comes to blockchain development. But if you do want to get more information on where you can start your blockchain development journey, we have another course that introduces you to all of these concepts on how to start building your own Web3 apps. We'll drop a link to that course down in the description below if you want to check that out. But some of the prerequisites that we recommend you have is have a basic understanding of Solidity if you do want to learn how to customize your own account factory contracts, and a basic understanding of Web3 development. We will be utilizing tools like thirdweb throughout this course, which makes it easy to follow along as long as you have a basic understanding of web development. But at any time in this course, if you feel like you don't quite get it, again, we recommend taking our How to Become a Blockchain Developer course. We'll add that down in the description below so you can check that out. And with all of that being said, let's start our course, and let's first start by learning what is account abstraction. So in this section, we're going to be covering what is account abstraction. Now, before we jump into explaining exactly what account abstraction is, we need to go back a little bit and understand the reasonings on why account abstraction was created. Now, when it comes to interacting with the blockchain, many of us are familiar with EOAs, or externally owned accounts. You're probably most familiar with this by using wallets like MetaMask, Coinbase, or other Wallet Connect wallets. And essentially, an EOA allows you to initiate and execute transactions on the blockchain. Now, the thing with EOAs is they didn't give you the best user experience. First off, it was very hard to create an EOA. You have to end up going to a website to create a specific wallet. You then have to save something like a seed phrase, which is a randomly generated 12, 18, or 24 list of random words, and you had to keep that seed phrase stored in a secure place, because with that seed phrase, you could access everything within that EOA. On top of that, your wallet also has something called a private key, which it used to sign transactions on the blockchain. Now, if at any time someone got access to that private key, they could then gain access to your wallet and start signing transactions on your behalf. So this brings up the issue of security, because you had to make sure that you stored these things very securely and that no one else got their hands on it. Another thing with EOAs was you had to have the funds in your wallet in order to execute or initiate transactions on the blockchain. If you're familiar with blockchain transactions, they are associated with something called gas, and that is a fee that you have to pay in order to execute a transaction on the blockchain. Now with EOAs, you had to make sure you had these funds readily available in your wallet. On top of that, anytime you wanted to interact with the blockchain, you had to sign a signature, whether it was signing a signature of approval or signing a signature to confirm a transaction. Every transaction needed to be approved before executed. So with all of that, the limitations and challenges of EOAs became very visible. Poor security, meaning that you had to keep things like your seed phrase and your private key secured, because again, if anyone else got their hands on it, they would have access to your EOA and all of your assets within it. Then there was the limitation of customization, the lack of customization, where every single transaction that you wanted to do on the blockchain had to be signed by your EOA, and you couldn't do things like automation when it came to transactions. Gas was another challenge, because again, a user had to have the funds available in their EOA in order to cover the gas fees needed for the transaction. And with all of this, this led to a poor user experience. If someone wasn't familiar with how to use these wallets, it was a very steep learning curve in order to learn how to. And with all of these limitations and challenges, this is what led to the creation of account abstraction. So what is account abstraction? So basically, instead of using your traditional wallet or EOA, you would use a smart contract as your wallet instead. And because your wallet was a smart contract, this means you could add your own logic and code to the smart contract and give your smart contract wallet some features and functionality that you normally wouldn't get with an EOA. And many of the limitations and challenges of EOAs were addressed with account abstraction. For poor security, you no longer needed to keep track of a seed phrase or a private key. Instead, you have the ability to create recoverable wallets if you needed to program that into your smart contract. With the limitations of customization, you could now sign once, and that signature would now apply to future signatures. And you could also build automation on top of your smart contract wallet. For gas, you now had the ability to sponsor gas on behalf of the user. So as the developer who was creating this account abstraction, you could then supply the gas fees needed for transactions used by your users. No longer did a user need to know how to fund their wallet with cryptocurrency. You can take care of all the gas fees for the user and they don't have to see it. And on top of that, you can actually remove the ability to need to sign transactions at all. So account abstraction really tackled the limitations and challenges brought to us with EOAs, allowing us to have a better user experience. This meant that the onboarding process to bring users who weren't familiar with Web3 applications or not knowing how to use EOAs now could have an easier time using a Web3 application. Now, at first, account abstraction was a little bit challenging too, because you still needed an EOA wallet to still create a smart contract wallet, which meant you still needed to know how to use an EOA in order to use these wallets. But even now, and you'll learn this later on in this course, we have the ability to use different types of wallets like embedded wallets, which allow email or social login to generate a wallet for the user, or something that thirdweb calls a local wallet, which generates a wallet locally on the device the user is using. And we can use these wallets as an EOA wallet to the smart contract wallet. This means we can fully remove the need for something like a MetaMask wallet, and you can now provide an experience where a user just needs to log in with an email in order to start using your Web3 application. So again, account abstraction really tackled these limitations and challenges. And later on in this course, we're going to learn how to build our very own Web3 applications using this and creating login flows where a user will follow a flow that they're very familiar with, just as they would in a Web2 application. So an overview of what we covered in this section, we simply went over why account abstraction came up to be because of the limitations and challenges brought to us with EOAs. We also went over a very high level of what account abstraction is. Essentially, they are smart contract wallets. And because they are smart contracts, we now have the ability to code our own logic and everything into them. So in the next section, we'll take a deeper dive into exactly how account abstraction works so you can have a better understanding of all the technical nuances of it. So with that being said, we'll see you in the next section where we'll go over how account abstraction works. In this section, we'll be going over how account abstraction works. Now, in the last section, we covered more of a high-level view of what account abstraction is. Essentially, it is a wallet powered by a smart contract versus what we were used to before, which was EOAs, which brought its own challenges, especially for a user experience. Now, before we jump into going over how account abstraction works, we'll take a look at how transactions were processed with EOAs, and we'll be able to compare that to how account abstraction works. So let's go over how transactions would normally work with an EOA. So let's just say person A wants to send tokens to person B. So from their wallet to another wallet, they would execute that transaction. They would have to sign off with it with their private key, which would then generate them a transaction hash, which would then be fed to a mempool, where it would be picked up by miners and added to a block, which would then be added to the blockchain. So within this transaction, again, we talk about private keys. A user is using their private key from their EOA to sign off on the transaction. And in the last section, we explained some of the security risks that came with. Another thing is a user had to pay for the gas. So a user, in order to send that token from their wallet to another wallet, would have to have had some native tokens funded in their own wallet in order to cover the gas fees. Now, just to execute this simple transaction comes with some challenges and issues, which we covered in the last section, mainly being the user experience. First off, the user has to have an EOA wallet. That comes with its challenges in itself, having to go to a website to generate your own wallet or create one, having to save your seed phrase, learning how to keep it safe. It also comes with the challenge of funding your wallet with a native crypto token. So if you're on the Ethereum network, you would have to fund your wallet with ETH. And if you're on any other network, you would have to fund your wallet with that native token. So someone would have to know how to receive or fund their wallet with cryptocurrency. And they would also have to understand the concept of gas. Gas fees is a new concept introduced to Web3. So with all of these challenges brought up something called EIP or ERC4337. Now, within this video and within the Web3 space, you may hear different terms associated with account abstraction. You may hear account abstraction, EIP or ERC4337. You may also hear smart contract wallets, smart wallets, even smart contract accounts or smart accounts. Just know that all of these terms mean the same thing, and you might hear the terms like smart contract account or smart account associated to the contract that is generated for the user. But now that we've taken a look at how EOA transactions work, let's now take a dive and learn how account abstraction transactions work. So very similar, we can have a user who wants to send a token from their wallet to another wallet, and we'll call these transactions a user operation. Now, a user can have many user operations, and these user operations, just like a EOA, get sent to a mempool. Now, this mempool is a different mempool than the standard mempool used for EOA transactions. This is an alternate mempool or a user operation mempool. From there, you have something called a bundler. And essentially what this bundler does is take the user operations and bundle them together to create a bundled transaction. Now, once the bundler has this bundled transaction, it is then sent to something called an entry point. And this entry point is a smart contract on the network, and each network has only one entry point. And what this entry point smart contract does is essentially validate your bundled transaction. So the entry point is going to check a few things. One, was that bundled transaction from the user actually signed off by the user? Two, it's going to check with something called the paymaster. And with something called a paymaster, just like how we explained some of the benefits of account abstraction, the user doesn't have to fund their wallet with the native token in order to cover gas. you can actually cover gas on behalf of your user. So essentially what a paymaster does is cover the gas of the user and their transaction. So once that is signed off and approved, the entry point can then execute the bundled transaction. And that's how account abstraction or smart contract wallets essentially work. Very similar to how an EOA transaction works, but with a few differences, allowing the user experience to be much easier. At the end of the day, account abstraction or smart contract wallets still need an EOA wallet to be created. And essentially this EOA wallet still has to sign off on things to execute transactions. But like mentioned in the last section, we have things like embedded wallets, which will allow a user to generate a wallet and connect it to their smart contract wallet as the EOA. And this will allow things like signless transactions, meaning that a user doesn't need to still create an EOA wallet like a MetaMask or a Coinbase wallet. With the combination of an embedded wallet and smart contract wallet, you're able to, again, sign in with an email and have a wallet generated for you. So with the combination of embedded wallets and smart contract wallets, you get the combination of signless transactions and gasless transactions if you decide to cover that with something like a paymaster. So again, account abstraction tackles a bunch of these user experience issues that we had with EOAs. And throughout this course, we're going to learn how to actually implement these into our Web3 applications. We'll cover how to implement them with regular EOAs like MetaMask, Coinbase, or Wallet Connect, but we'll also learn how to implement this very unique flow with embedded wallets, creating a very seamless and unique Web3 user experience that someone with no Web3 knowledge can still enjoy. So that covers this section on how account abstraction works. And in the next section, we'll cover why you may want to use account abstraction for your Web3 application and some of the unique use cases that you can use or think about when implementing account abstraction into your Web3 project. In this section, we'll be going over the why for account abstraction. We covered some of the reasons why in the past two sections, but in this section, we want to cover some of the use cases that maybe weren't mentioned in the past sections. So again, account abstraction was really built to help the user experience when it came to interacting with Web3 applications. And one of those benefits came with the easy onboarding process. Like mentioned in the past two sections, with something called embedded wallets, we can now create this seamless login flow where a user can log in with an email, which then generates them a wallet to then use with their smart contract wallet. And nowhere in that process will they have to go to a website or anything to generate or create their own EOA wallet. Along with embedded wallets comes some benefits like signless transactions. And if you enable gasless features with your smart contract wallet through something like a paymaster, you can even create gasless functionalities as well, allowing you to interact with a Web3 application without having to sign or pay for gas. Another benefit or use case for smart contract wallets is being able to have multiple EOAs control one wallet. This means that you can have one wallet where you can have multiple EOAs, and those multiple EOAs can have the ability or permission to sign off on transactions. On top of that, you can add restrictions to your smart contract wallet, like maybe restricting what smart contracts this wallet can actually interact with. Maybe this wallet can only interact with a handful of specific contracts. You can specify that within your smart contract wallet. And you could also add restrictions like a spend amount or a spending cap. This could allow things like a team wallet where a team could have access to a smart contract wallet. Each member of the team has their own position and their own restrictions and permissions that they're allowed to do with that smart contract wallet. And this would allow for collaboration without anyone being able to execute things that they aren't able to do. At the end of this course, we'll also go over something called session keys, which is similar to like what we were talking about, allowing permission for multiple wallets to access a smart contract wallet, but you could add things like session limits. So maybe an EOA only has a time limit or a certain amount of time that they have to access or have permission to use the smart wallet that they were given the session key for. Some other features of smart contract wallets or smart wallets, which is what we're going to be using in thirdweb, is that normally when you generate a smart contract wallet, they won't be deployed until they actually execute their first transaction. So what does this mean? So normally when a smart contract wallet is generated, it needs to be deployed, meaning that you need to pay the gas to deploy the actual wallet. Because again, the wallet is a smart contract. Now with smart wallets, with thirdweb, you're able to determine what the smart contract wallet address or contract address is. This allows us a few benefits. One, we'll be able to still send tokens or NFTs to the wallet address. The user can still access their wallet even though the smart contract wallet hasn't been deployed. And again, some other use cases that you can program into your smart contract wallet are things like recoverable accounts and also being able to automate transactions as well based on other blockchain events. So again, there are a bunch of use cases and benefits that come with account abstraction and why you may want to implement them into your Web3 project. Now that does it for our introduction part of this course. Again, we covered many things from what is account abstraction to how account abstraction works and to some of the use cases and reasons why you may want to implement it. Now going on to the next section, we're going to learn about something called an account factory contract. Now these contracts are going to be used to help us deploy our smart contract wallets. Now with thirdweb, we have a few different account factory contracts that you can use, and we'll be covering what each one is and comparing them to each other. After that, we'll start to implement smart contract wallets using thirdweb smart wallets into our applications. Again, down in the description below, we have all the timestamps for this course. So if you need to go back and watch a section to better understand some information, or if you want to skip ahead to a certain point, you can always check the timestamps down in the description. But with that being said, let's jump into the next section and get started. Hey everyone, and welcome back to the next section of our course. And in this section, we're going to start implementing account abstraction into our Web3 applications and projects. Before we do set it up with our Web3 project, we will have to deploy ourselves an account factory contract, which we went over in the last section. We'll then have to set up a thirdweb API key, which we'll go over in this section. And then we'll implement smart wallets, which is thirdweb's account abstraction wallets or smart contract wallets into our Web3 applications. We'll be implementing them into 3 different types of applications. We'll first start with our web applications using React. We'll then implement them into our mobile applications using React Native. And we'll also show you how to implement smart wallets into games using Unity. And we'll be implementing this the easiest way using thirdweb using our Connect Wallet button. Our Connect Wallet button is a UI component that is a Connect Wallet feature ready to go out of the box. And we'll show you how easy and quickly you can implement smart wallets into your Web3 applications. So with all that being said, let's jump onto the computer here. Let's deploy ourselves an account factory contract and set up our API keys. So right over here on my computer, I am on the Explore page, and we're going to scroll down until we reach the section called Smart Wallets, where we'll have our 3 different type of account factory contracts. Again, we went over these 3 different types in the last section. I'm just going to deploy myself a simple account factory contract here. So I'm going to click on it. I'm going to hit deploy now. Now we went over these configurations. Here I am going to uncheck deploy deterministic address for this, and I'm going to deploy this to the Mumbai testnet. I'm going to select deploy now. I'm going to confirm the transaction to deploy. I'll then sign this to add it to my dashboard. Once it's been deployed, you'll be brought to your account dashboard. You can see here, this is our account factory contract. I'm going to copy our contract address here. We'll need that later on when we need to add it into our application. And that's all we need to do here for our account factory contract. The next thing we need to do is set up our thirdweb API key. So over here in the top tabs, we're going to head to the settings tab, and you'll have on the left-hand navigation here, API keys. And API keys are required to use thirdweb services through our SDK and CLI. Now I'm going to create a new API key here. We're going to name this. I'm just going to name this account abstraction course key. I'm going to hit next. Now we'll be able to enable a few different services here. One being storage if we need to upload or download storage to our IPFS, if we want to use thirdweb's RPCs. What we're going to really focus on here are these bottom 2 is smart wallets and embedded wallets. So for smart wallets here, we can make sure that this is toggled on, and you can see here that we have allowed contract addresses. So in this field here, we can enter in different contract addresses we want to allow our smart wallets to interact with. If you remember in previous sections, we have control of the permissions that we allow to these smart wallets. So here we could say, hey, the smart wallet can only interact with this ERC20 contract or maybe this ERC721 contract. We can add in whatever contract addresses we want in here. For now, we're going to uncheck this and we're going to leave it as unrestricted, meaning that it can access any smart contract. Now down here below that, we have embedded wallets, and embedded wallets is going to allow you to generate a user a wallet via email or social login. And this makes it easy for easy onboarding because a user, again, doesn't need to create a MetaMask wallet or an EOA wallet in order to connect and deploy their smart wallet. So we're just going to make sure that is toggled on and we're going to hit next. Next here, we have to set access and restrictions for our domains and bundle IDs. So domains is going to be for web apps. So this is if you want to restrict the domains that your API key is going to have access to. For this tutorial and everything, I'm just going to uncheck restricted access. If this key is going to be for a production app and you only want it to work with your application, then you will put in your domain here, or you can put in your local host that you're going to be deploying and running your application on. But just to make things easy here, I'm going to hit unrestricted access. I'm going to do that for the bundle IDs as well. This is going to be for your mobile apps and your games. So iOS, Android, and your Unity games. You would add in your allowed bundle IDs here, but we are going to just leave it as unrestricted access here just to make things easy for these tutorials. Once I'm done with this, I'm going to hit create. And you're going to be given a client ID and a secret key. Now, this secret key will only be generated once, and you don't want to share this secret key because, again, you can't regenerate this key here. And this is going to be for authenticating your application from the backend. But what we're mainly going to be using throughout our tutorial is these client IDs here. But we're just going to save the secret key on the side just in case. And I'm going to save the client ID here as well. Then we'll check off that I have stored my secret key safely, and there you go. We now have our API keys. We're going to head back to our Explore page one more time, and I'm going to deploy myself an addition drop contract, and this is a claimable ERC1155 contract. Now, I'm going to be deploying this contract here just for testing purposes. This way we can test claiming NFTs throughout the tutorial videos, and we can check and see how smart wallets actually work. So I'm going to click on addition drop here. I'm going to hit deploy now, and I'm just going to call this a course collection, and we'll just call that AA. And I'm going to leave everything here the same. I'm going to make sure I deploy this to the same chain that my smart wallet or my account factory contract was deployed to, which is Mumbai. And I'm going to deploy now. I'm going to confirm the transaction here, and I'll sign to add this to my dashboard. Once that is deployed, we'll be brought to our contract dashboard here. I'm going to copy my contract address here, save it on the side so we can use it throughout this tutorial. And what I'm going to do is come over to the left-hand side here, select NFTs, and we're going to upload a single NFT here. I'll just call this NFT1. I have an image here of a pineapple, and I'm going to lazy mint this NFT. And what I'm going to be doing with this NFT is, we'll confirm this to mint, is I'm going to be setting the claim condition to free, and we're going to set the supply to unlimited, so we can just always test claiming with this ERC1155 token. So once that's deployed, I'm going to select the NFT. We'll then head to the claim conditions tab here, and we'll add a phase, and I'm going to make this a public phase. And again, leave it as unlimited. We'll make it free, and we'll leave unlimited claims per wallet. So we'll hit save phase here. Confirm that transaction. And there we go, our phase is saved. So we now have everything set that we need for setting up our smart wallets. We have our account factory contract deployed, we have an API key, and we deployed a demo ERC1155 contract that we can test claiming NFTs with our smart wallets. So in the next section, we'll be implementing this first into our web applications using React. Hey everyone, and welcome to the next section of our account abstraction course. And in this section, we're going to be covering something called account factory contracts. Now in the previous section, we went over what is account abstraction, how it works, and some of the use cases on why you may want to use something like account abstraction in your Web3 application. Now, from this point on, we're going to be learning a little bit more on how to implement account abstraction or smart contract wallets into your applications or projects. And the first thing you're going to need is something called an account factory contract. Now, like we covered in the previous sections, account abstraction wallets are essentially wallets that are smart contracts. And what an account factory contract is, it's a factory contract that allows us to generate these smart contract wallets for our users. So before we're able to implement them into our Web3 projects, we'll have to create or deploy one of these account factory contracts. With thirdweb, we offer a few different types of account factory contracts. And in this section, we're going to cover what they are, how they're similar, and how they're different, and help you decide which one you will need to deploy for your Web3 project. So right here on my computer, we are looking at our documentation. We'll have the links to these down in the description below. So if you want to read up on what we're going over, you can check it out as well. But we are in our docs here, and we're looking at our smart wallets. And we're under this section here that we're going over smart wallet factories. And in this case, this is what our account factory contract is. You can see an account factory contract must be deployed, and it's responsible for deploying individual user contracts. And those individual user contracts are going to be the smart contract wallets for our users. So there are different types of account factories. We have 3 different types here that you can deploy using thirdweb. The first one is a simple just account factory contract. Then we have a dynamic account factory contract, and then we have a managed account factory contract. Some of the things here that you'll see is the option of upgradability. So with the simple account factory contract, there is no upgrades. Once you deploy it, whatever logic you deploy that smart contract with is going to be what it is, and there's no upgrading anything in it. Now with dynamic here, you can actually have upgradable control, and you can then push out updates to the smart contract wallets that are generated from this account factory. Now with this, you're allowing the users of each of those smart contract wallets that are generated to have the option to accept these updates or not. So you can give an upgrade option, kind of like an operating system update, where you can give the option to the user if they want to upgrade with these new updates. They can accept or decline. So again, the dynamic is upgradable, giving the option to the user of the smart contract wallets. Now over here we have managed, and managed is upgradable as well, but the permissions is set by the parent or the owner of the account factory. So as the owner of the account factory contract, I can push automatic updates, and basically this will go across everything and all of the smart contract wallets that were generated. So differences between dynamic and managed, again, both are upgradable. Dynamic gives the permission to the owner of the smart contract wallet. Managed, the permission is the owner of the account factory, and it then is pushed to every smart contract wallet that has generated. You can see here that our simple account factory is just called account factory, and for the smart contract wallets it generates, they are called accounts. Then we have dynamic account factory with dynamic accounts and managed account factory with managed accounts. They are all ERC4337 compatible. They can all hold native ERC20, ERC721, and ERC1155 tokens. They all allow multi-signers. They can all execute batch transactions as well. You can see the difference though is the upgradability. The simple contract does not have the ability to be upgraded, while dynamic and managed do have the ability to be upgraded. And then you can see here the admin of the account has the ability to perform those upgrades in the dynamic, and then the admin of the account factory is the one who has the permission to those upgrades in the managed account factory. Now we'll also link this blog post down below, but this blog post goes over a deeper dive into our account factory contracts. You can take a look through this blog here, and you can see we have the same charts and here comparing the account factory contracts. But you can see here across all wallets, they share the same basic smart wallet capabilities. They are all, again, ERC4337 compatible, meaning that they implement the validate user operations function. They can execute single or batch execute multi-call transactions. They support EIP 1271 contract signatures and implement is valid signature as well. Again, like we mentioned, they have add deposit and withdraw deposit too for managing native token balances. And they also share the same permission model, exposing an is valid signer helper function that checks whether a given signer is eligible to use the account with a given user operation. And speaking of permissions, you can see here that there are two different types of permissions that are allowed on our smart contract wallets or accounts. And again, those accounts recognize two types. The first one being admins. Admins have unrestricted access to the account. They can call any function, they can use a contract going through ERC4337 infrastructure, they can withdraw the native token balance. They basically have all access to the account. Now, there is also non-admins with permissions. And like we mentioned in the previous sections, you can add permissions. And this is one of the benefits of using a smart contract wallet, where you can have a non-admin who has permission as just a signer, and you can set those permissions. And some of the permissions that you can set for a signer is going to be things like approved targets. So you can set a list of smart contracts or EOAs that the signer can call using the account. So maybe they can only interact with certain smart contracts, or they can only interact with certain other EOA wallets. Then there is also the permission of native token limit per transaction. So you can set limits to how much tokens the signer can actually use. So it's kind of like setting a spend limit that the person is allowed. Maybe they're only allowed to spend $100 of the balance within that smart contract wallet. And then there is start timestamp and end timestamp. And these are giving the start and end times in which that signer has permission to access the account. So we can say, hey, you only have from this day to this day, or maybe you only have 3 hours to have permission to spend a set amount of tokens only on this smart contract. So you can set these different types of permissions. And again, that's one of the benefits that you get when using smart contract wallets. So again, the links to these documentations and blog posts will be down in the description below if you want to check out more and read a little bit more about it. Next thing we're going to do is head on over to our Explore page, and our Explore page allows you to deploy our pre-built smart contracts from thirdweb. And we're going to be looking at our smart wallet contracts. Now, smart wallet, you're going to start to hear me use the term smart wallet as we go on through this course. Smart wallet is what we have named our account abstraction or smart contract wallets here at thirdweb. Once we start implementing this into our Web3 applications, you'll start to hear me using the term smart wallet instead of account abstraction or smart contract wallets. So under this section here with smart wallets, you'll see that we have the 3 different account factory contracts. We have the simple account factory contract, which is just called account factory. We have our dynamic, and we have our managed. To deploy them, it's very simple. You just select the account factory contract that you want to deploy. You can read a little bit more about it. You can see some of the information right here is the information that we just went over. And all we need to do is come up here to the top right, and we're going to select deploy now. And with deploy now, you can see here that we have some contract parameters that we need to set up. Now, under this network and chain, we just need to select the network we want to deploy our smart contract wallet to. Now, you can see here, we recommend using a testnet first so that you can test things out, make sure everything works properly. You can even do this if you want to test the different types of account factory contracts. Deploy them on a testnet so that you don't need to use real funds when deploying onto a mainnet. Now, you do have a few options here that you can check off. The first one is to add to dashboard, so you can find it in your list of contracts. I would recommend leaving this checked off. That way you can easily access this on your contract dashboard. We also have deploy at a deterministic address. So what this allows you to do is have the same contract address on multiple chains. So unlike your EOA wallet, a smart contract wallet, when you deploy an account factory contract, you have to deploy it to a single chain. And when you deploy it to a single chain, it's given a contract address. And the thing is, if you want that wallet to access another chain, you would have to deploy another account factory contract onto another chain. The thing is, if you don't have deterministic addresses, then you'll have a different contract address for a smart contract on Ethereum than you would a smart contract on something like Polygon. So if you want to be able to access different chains with the same smart contract wallets, you have to deploy them on deterministic addresses. And all you need to do here is make sure you have deploy a deterministic address, and you can have an optional salt input here. And you can also check off if you want to include the deployer address in the salt. We recommend that you keep that checked off. Now below here, you choose the chain that you want to deploy on. So we're going to choose a testnet here. We're going to actually use Mumbai. I'm going to switch networks here. And we do have a list of the networks or chains that you can deploy your Account Factory contracts to. We'll add that link down in the description below so you can check that out. But once you select the network and chain that you want to deploy to, all you need to do is hit deploy now. We'll get a transaction that pops up here. We'll confirm. And then we'll get a second signature request here. And this is the signature to add it to your dashboard. Once it's been deployed, you'll be brought over to your Account Factory dashboard. And you can see here, this is where you can manage your Account Factory contract. So with Account Factory contracts on the left-hand side here, under the extensions, you're going to have these two new tabs here called Accounts and Permissions. So under Accounts here, this is going to be where you'll see a list of the smart contract accounts that are generated by your Account Factory contract. We don't have any accounts here, but we could create account here. And what this will do is create an account here with our wallet address here as our EOA. So we'll just have to pay the gas here. And there you go. You can see that we have a new contract address here. And this is a smart contract account here. And if we click on that, it'll actually bring us to a new dashboard, which is the dashboard of the smart contract account. You can see this is an account contract. And with this, we can check on the left-hand side here, things like the balance of the wallet. You can see the native balance of the native token. We can deposit some in here. We can see the NFTs owned by that account as well. And we can also take a look at account permissions. And you can see here under account permissions, we only have the admin wallet, which is our EOA wallet. In this case, it's my MetaMask wallet right here. And then we can just go back to our Account Factory real quick. So back in our Account Factory dashboard, below accounts, we have permissions. And here in permissions, this is where we can start to set some of the permissions like our admin. So again, only our deployer wallet is the admin of this Account Factory here, but you can add more addresses as well. And you can set then the permissions for different functions like transfers, minting and creating, pausing, lister, assets, and a bunch of these other ones here. This is how you can manage your Account Factory contract. And you can also manage and view your accounts that are generated by this Account Factory contract. The same goes for dynamic and managed Account Factory contracts. And that does it for this section, overview of Account Factory contracts. We went over what they are, the different types of Account Factory contracts you can deploy using thirdweb, and we went over how to deploy your very own Account Factory contract. Now in the next section, we're going to start implementing smart contract wallets into our Web3 application using thirdweb's smart wallets. We'll go through an easy and simple way to implement them using thirdweb's Connect Wallet button. Then we'll also take a dive in how we can create custom flows using thirdweb's smart wallets. And again, if you need to rewind or rewatch any of these sections that we went over, we'll have links to the timestamps all down below in the description, so you can easily find the place that you need to rewatch or head back to. But with that being said, let's head on over to the next section where we'll start implementing smart wallets into our applications. Hey everyone, in this section, we're going to be building our very own custom connect flow utilizing smart wallets and embedded wallets. Now in the last section, we learned how to implement smart wallets into our Web3 application utilizing thirdweb's Connect Wallet UI component. The Connect Wallet UI component is a component that you can use that gives you a Connect Wallet button right out of the box that's ready to use. And with a simple configuration, we could add smart wallets to that Connect Wallet button. Now with thirdweb, we also have something called the Wallet SDK, which will allow you to create your very own Connect flow. This means that we don't need to create a UI component or use the Connect Wallet UI component, but with our Wallet SDK, we'll be able to build our very own UI and create our very own custom flow. So in this section, we're going to build that custom flow again using embedded wallets and connected to a smart wallet. We're going to build a login card, which just has a user input their email. We'll then have a login button. And when they log in, they'll be sent an OTP or a verification code that they need to then verify. And that will then connect their embedded wallet to their smart wallet onto their application. So that being said, we are going to be using the smart contracts that we deployed in the getting started in the last section. So we deployed ourselves an account factory contract. We also deployed a ERC4337 contract. This is just a demo NFT contract that we're using to test claiming. And we also generated our very own thirdweb API key. So if you don't have those things, you can head down to the description below. We have timestamps, and you can head to the getting started section where we deployed those contracts, and you can deploy them for yourself. So with that being said, let's jump on the computer here. Let's first take a look at a demo of what we're going to be building, and then we'll jump into the code. So right here on my computer, you can see we have a login card that's asking for an email and a login button. So this here is actually utilizing our embedded wallet login flow. And all we're going to do is put in our email. So we'll just put in our email here. And when I hit log in, it's going to send us an OTP. We have to then verify that OTP. So I'll wait for the email here. And again, what this is doing is generating us a wallet using our email, and then it is connecting us to a smart wallet. So right here, you can see we have a logged in. I have some data showing of our personal wallet and showing the wallet address of that personal wallet, which is our embedded wallet. And we have some information here of our smart wallet, which this is the address of our smart wallet. Now, at the very top, this is actually a Connect Wallet UI component. You can see here it has the smart wallet of 5FB5, same wallet and information that we're showing down here. And the reason we added this into this demo here is to show you that even when you create your own custom login or connect flow, you can still use the Connect Wallet component, and the Connect Wallet component is still usable and still access all the same functionality that you would if you were to have used this initially for the connect flow. So you can see here we have our wallet, and then we can switch to our personal, which is the 080F, which is the same wallet that we have here for our personal wallet. Now, under each of these personal wallet and smart wallets, we have a claim NFT button and we have a quantity. Now, why are there two different ones under both of these? So in this tutorial, what we're also going to go over is how you can utilize smart wallets as, in a way, a relayer for your Web3 application. So normally, if we look at smart wallet here, if I were to claim an NFT, I would claim an NFT to the smart wallet address. And I can use logic like, hey, I can only interact with certain smart contracts. And I could also enable things like gasless transactions. So I won't need to pay for gas when I claim this NFT to my smart wallet. So if we're to test this out right now and we're to claim one, again, we're using embedded wallets, so we don't need to sign any transactions. And we have gasless enabled, which means we don't need to pay for gas for any of these transactions, meaning that once I claim this NFT, we should see the quantity or the owned NFT for this smart wallet increase to 5, which we see right here. Now for personal wallet, what we can do is use the smart wallet as a quote unquote relayer, and we can still use the same logic and features and functionality of a smart wallet. So we can still do things like, hey, you can only claim NFTs from this contract. We have gasless enabled, but instead of claiming it to the smart wallet address, we can still claim it to our personal wallet. This means that a user can then take their personal wallet, still go to other Web3 applications like OpenSea or something, and still access the NFT assets within their own personal wallet. But you get to execute the transactions using the smart wallet on the application. So if I were to hit claim NFT here, again, it's still a signless transaction because we're using embedded wallets. If you had a MetaMask or something connected, you would still need to sign that signature. But we have gasless enabled through smart wallets, so we're still being able to use that functionality. And you can see here we claimed an NFT and we increased the quantity here to 2. Again, you're not tied to using only the smart wallet within your application. You can still use it as a way or a relayer to send the digital assets to the personal wallet that is the EOA wallet of that smart wallet. So again, this is a demo of the app that we're going to be building. And with that being said, let's start building it. So I'm in my terminal here and we're going to create a new project. So I'm going to run npx thirdweb create app, and we're going to name this smart wallet custom. And we're going to use Next.js and TypeScript for this tutorial. And once that's done, let's just clear out of this. Let's change into our smart wallet custom connect, and let's open this up in our code editor. So in my code editor here, we're going to set up our application first. So we're going to do a few things. The first thing we're going to do is in our pages folder in the _app.tsx file, we're going to set up our third web provider. So here, the first one is our client ID, and we're storing this in a .env file. So in our files here, we'll go to the .env.example, and you can see here we have our next public template client ID. So we're going to take our client ID that we generated, which is our third web API key. We're going to save that, and then we will head back to the _app.tsx. The second one is the active chain, and that over here, we are going to set up our active chain here. By default, it's on Ethereum. You'll change this to the chain that you deployed your contracts to. In my case, I deployed to the Mumbai testnet, so I'm going to switch that over to Mumbai. Next, I'm going to, in my file directory, create a new folder, call this constants. And in that constants folder, I'm going to create a new file called addresses.ts. And what I'm going to do in this addresses.ts is store my account factory address and my NFT contract address that we're going to be claiming from. And again, we deployed this in the last section, in the getting started section. So I'm going to grab my account factory contract address, paste it in there, and my NFT contract address, and paste that in there. And this is so we can use these throughout our application. Next, what I'm going to do is back in the _app.tsx file, we're going to set up some of the configurations needed to use the smart wallets. So in here, I'm going to set up a smart wallet config. And again, we're going to provide this with our factory address, which is our account factory address that we just made. And then we're going to set gas list here, and we're going to set gas list to true. Now in third web provider, in order for us to still use that connect wallet button after and display our wallet's information when it's connected, we are still going to need to put the supported wallets. We're going to give it an array of the supported wallets. And in this case, we're going to do wallet, smart wallet, with our embedded wallet and our smart wallet config. So we'll leave that right there. We'll actually do, if we come here, and in this example too, I'm going to do one more. I'm going to do a smart wallet with MetaMask and smart wallet config. So now we have our application set up. If we come back to our demo app here, I'm going to sign out here. First thing we're going to do is build this login card right over here. So coming over to my files in the pages folder, I'm going to select the index.tsx file. Now, if I run, open my terminal and run yarn dev here, we do get given some templated code here when we create an application through third web. So we look here, this is the templated code that we get, but this is what we're going to be removing. So if we come back to our code editor, right over here, I'm going to remove everything within this div tag that has the styles of container. So I'm going to remove all of this, and we'll delete that. We'll delete some of these imports that we are no longer going to need, like image and connect wallet. And we're going to build ourselves our application or our login card first. So over here, I'm going to first create a variable called embedded wallet config. And this is going to be an embedded wallet. And what we can give this here is some styling. So when we get our OTP and everything, when we get our OTP modal that pops up, we can give it some styling here. So we're just going to give it some styling like border radius, background color, and change the text. Next, what I'm going to do is actually come back to my _app.tsx, and I'm going to copy this smart wallet config. And we're going to paste it right in here one more time and import our account factory address. So now I have my embedded wallet and my smart wallet config. And with those two, we can now create our very own custom flow to log in and connect the wallet. So in our app here, we're first going to create a variable called address and use a React hook called use address, which will get us the wallet address of the connected wallet, and also check if we have a wallet connected to our application. We'll also create a variable for connect here, which is going to use the use connect hook, which is the hook that we're going to use to connect our embedded wallet and smart wallet to our application. Next, I'm going to create some state variables. The first one is going to be for our email input, and we'll import use state here. The next one is going to be for our personal wallet address. And this is going to be, we'll specify that it'll be a string or undefined. And by default, it will be undefined. And then we'll do the same thing here for our smart wallet address right here. So those are going to be our state variables for our email input, our wallet address, our personal wallet address, and our smart wallet address. So now we'll build our login card. So in that div with the container styles, we'll check if we have an address or a wallet connected to our application. And if we do, we're going to create a component, that login component. But if we don't have a wallet connected, this is where we're going to create our login card. So I'm going to create a div here, and I'm going to copy some styles that I have. So I have some styles here just to make our application look nice throughout this tutorial. You can copy the same styles. There'll be a link down in the description below to the repo here. Or you can add your own styling that you want to your application, but I'm going to come in here and just paste in our own styling. And we'll come back here, and then this div is going to have a class name of styles.centered container. Within that, we're going to have another div. This one is going to have the class name of styles.centered card. It's going to have a title here of login. We'll put some text under here and have it say, enter your email to log in. And then below that, we'll have an input. It's going to be of type email. And then we'll just drop this down here. It'll have a placeholder of enter your email. The value here is going to be our email input, and we'll have it on change to change that value to whatever is in this input here. Then below that, we will add a button. This button is going to say login, and we will then code the function of this button in just a bit. But we'll take a look at our login card. So if we come back to our app here, you can see here we have our login card. It says enter your email to log in. We can input our email here, and then we have a login button. Now, this button doesn't do anything because we haven't created the function to connect to our smart wallet yet. So coming back to our code editor here, let's now create that function to connect our smart wallet to our application. So I'm going to create a function here. We're going to call this handle login, and it's going to be an async function. And what we're going to do in this function is we'll run a try catch. We'll just console log the error if there is any. Now in the try here, we're going to first connect our personal wallet or our embedded wallet to our application. So I'm going to create a variable here called personal wallet, and this is going to equal await. And we're going to use the connect hook here, which is our use connect hook that we created right up here. And what we're going to connect is our embedded wallet config, which was the embedded wallet config that we made up here. And with that embedded wallet config, we're going to add some connect configs. Now, the connect config that we're going to add for this is the chain ID. And the chain that we're connecting to is Mumbai, which is 80001. We're going to put in the login type. And now the login type for this, we are going to use the UI email OTP. And then we're going to give it the email. And then for the email, we're going to provide it with our email input. Now, if we don't provide this connect option here and we just passed our embedded wallet config, it will still work. But a modal where a user has to input their email would show up. So it defeats the purpose of us creating our own UI with a allowing the user to input their own email. So if we specify here the login type and we provide it with an email already, it'll bypass that part of prompting the user to enter their email, and it will just send them directly to verifying their OTP. So that's what this connect section, the connect option here, is going to be for. After we connect our personal wallet, we are going to create a variable here called our personal wallet address, and we are going to await, and on our personal wallet that we just connected, we are going to get address. And then we are going to set the personal wallet address to that personal wallet address. And then we're going to connect our smart wallet. Now, similar to what we did above, we're going to await connect here. And we are going to connect our smart wallet using our smart wallet config. And then we need to provide it with our connect options. And in this case, we're setting the personal wallet to our personal wallet. And we're setting the chain ID to Mumbai, which is 80001. If we look at our smart wallet config, so if we come back up to our smart wallet config, we're going to actually have to specify that this is going to be a smart wallet utilizing our embedded wallet config, and then we'll pass our connection there. So there we go. We just need to specify that it was going to be a smart wallet using our embedded wallet here, and then our factory address and gas list, and there we go. Now we can connect that smart wallet config and then tell it that we're going to use the personal wallet, which is the wallet that we just connected up here, which was our embedded wallet. That's going to be use our personal wallet, and we'll specify the chain ID. Then the same thing here, we're going to get our smart wallet address and await our smart wallet, and then get the address, and then set our smart wallet address to our smart wallet address. Once that's done, we'll also set our email input to a empty string again. And that does it for our function to handle our login. So again, we're going to come down here. We're going to come to our button. And on our button, we're going to on-click, run our handle login. So once we're logged in, we'll just display a connect wallet button. And because we are using the use connect hook, again, we'll be able to, once we have a wallet connected, still use the connect wallet UI component. So once we connect, we'll see the connected state of the connect wallet UI component. So I've saved that. I'll come back to my application here, and let's test this login. So we can log in with our email. We'll hit login. We'll then be prompted up to enter our OTP. Once we verify that, again, we are going to connect with our embedded wallet, and then use that embedded wallet to then connect to our smart wallet. So there we go. We now have connected, and we see our connect wallet button, but in the connected state. And you can see here, we now have a new smart wallet with the address 2855. We switch to our personal wallet. We can see our embedded wallet right over here. So again, we just created our own custom flow to log in to our application. We created a UI that looks to a user just to input an email and verify an OTP. So again, you're able to create your own custom UI and connect flow using the wallet SDK from thirdweb. And we can still utilize the connect wallet button and everything up here. So now let's build our connected state like in our demo here. So in our demo, if we connected to our account again, we're going to build this card right over here. So coming back to our application here, and then coming back to our code editor, let's build out that second part. So what we're going to do before we build that out is we're going to need to get some information, because we are going to display the quantity of owned NFTs that the wallet has. So we're first going to get our contract that we're checking the quantity for, and we're going to use the use contract hook from thirdweb, and we're going to provide it with our NFT contract address. Then we're going to get the owned NFTs. So we're going to get our data and rename this owned NFTs. We can check is loading owned NFTs, and we'll actually name this personal owned NFTs. And this is going to use the use owned NFTs hook here. And we're going to do this on our contract that we just got. And we're going to provide it with our personal wallet address. And then the second one we're going to do is the same thing, but for our smart wallets. So smart owned and then a smart wallet address. So right over here, instead of showing this connect wallet button, I have added in a div with the centered container and centered card again. At the top, we have displayed our connect wallet button. We have some text that says logged in. I'm then going to show the personal wallet and display our personal wallet address. Below that, we have a Web3 button that is going to interact with our NFT contract address. And it is going to, on our contract, call the claim function to our personal wallet address. And it's going to claim token ID 0 and the quantity of 1. So instead of the claim function, we're going to call the claim to function. And this is where we can specify the wallet address we want it to be claimed to. So instead of claiming it directly to our smart wallet, this button is going to claim it to our personal wallet address. And then below that, we're going to display the quantity of owned NFTs by mapping through our NFTs and displaying the quantity owned. Same thing goes for our smart wallet here. We're going to have a Web3 button that calls just the claim function, not the claim to. That will claim it directly to our smart wallet address. And again, we will be displaying our owned NFTs. So coming back to our application here, we can sign into our wallet. We'll verify our one-time password. And once we're logged in, you can see here we're logged in. We have our information of our personal wallet, our smart wallet, and we have our connect wallet button up here that displays the information of our connected smart wallet. Now you'll see here in smart wallet, we actually have a quantity of 1, and this is because we're using the same account factory contract, the same API key that we're using throughout our other sections, and we had already claimed 1 NFT to this wallet. But again, here you can see this is wallet 2855. So if we were to come back to our account factory contract here and we look at our wallets, you can see here that's the 2855, which was the embedded wallet that we used with our smart wallet back in the previous section. And that's why we have 1 NFT claimed here right now. So if I were to, again, we can test this out. We can claim an NFT to our smart wallet. We have gas list turned on. We have embedded wallet, so we don't need to sign any transactions. So once this transaction goes through, we should see the quantity of our owned NFTs in this wallet increase to 2. There you go. We now have 2 NFTs here. And just like we said before, we can claim 1 to our personal wallet, utilizing our smart wallet to execute the transaction, giving us all the perks of a smart wallet, but being able to claim an NFT to our own EOA wallet. So if I were to hit claim NFT here, there you go. We claimed the NFT, and now our personal wallet owns 1 of these NFTs instead of our smart wallet. Now, what does this look like if we did something like use our MetaMask instead of an embedded wallet? So I'm going to log out here, and we're going to switch up our handle login flow here. So for our personal wallet, we are going to first connect here. Let's create our, let's do MetaMask config, and this is going to be here a MetaMask wallet. And we will then over here for our personal wallet, connect our MetaMask wallet config. So this will just be a MetaMask connect instead. And I can come back to my application. So I don't need to input an email here because we just made it so that our login button will connect to our MetaMask. So I've hit login here. You can see that we logged in with our MetaMask here. And then I connected to my smart wallet, which is the CDD7. And coming back to our account factory contract, that is the first wallet that we have up here, which was when we had first tested MetaMask connecting to our smart wallet. And that is why you see here that the quantity is 1. So if I were to connect to a Web3 application utilizing smart wallets, I could still claim a NFT to my MetaMask wallet by using the claim to and specifying the personal wallet as the destination for that NFT. So I hit claim NFT here. Again, we have gas list transactions turned on. With MetaMask though, we are going to have to sign a signature. So we'll get a signature request that pops up in our MetaMask. We just have to sign it there. And then our transaction will go through. We'll be able to claim an NFT to our MetaMask wallet, utilizing again our smart wallet to execute that transaction. And there you go, our MetaMask wallet now has one NFT. So there you have it. In this section, we were able to create our very own custom connect flow or login flow for our Web3 application. We were able to create a login where a user had to simply put in their email, hit a login button, and what that did was created an embedded wallet, connected to a smart wallet, and then logged them in and connected them to our Web3 application. We also went through how you can use a smart wallet, kind of like a relayer for your Web3 application, allowing a user to still use their EOA wallets like MetaMask or an embedded wallet or Coinbase wallet. And instead of claiming digital assets to their smart wallet, they can now claim their digital assets or NFTs directly to their EOA wallet. You still get the perks of all the functionality and features of smart wallet, like setting permissions on which smart contracts the smart wallet can actually interact with, along with features like gasless transactions. So again, that does it for this section. If you need to go back and rewatch any of the previous sections, again, just a reminder that we have all the timestamps down in the description below. Now in the next section, we're going to go over creating our very own custom account factory contract, adding our own custom logic to that contract, and then creating a very unique and custom flow for our users to log in to our Web3 application. So with that being said, let's hop on over to the next section and get started. So in this section, we will be implementing smart wallets into a Web3 web application with React. Now, if you didn't watch the last section of getting started, we deployed the necessary account factory contracts and got a thirdweb API key, which will be needed in order for this implementation. So if you haven't watched that yet, head back to the last section, make sure you deploy those contracts and you get your API key, and then you can follow along. So on my computer here, I have my terminal open, and we're first going to create our project here. So I'm going to run npx thirdweb create app, and we're going to build ourselves a web project here. So I'm going to name this smart wallet React, and we're going to use Next.js and TypeScript for this. And once that's done, we'll change into our smart wallet React here. And we'll open this up in our code editor. So the code editor open, we just need to set up a few things before we get started. So heading into the pages folder, we're going to head to the _app.tsx file. And in this _app.tsx file, we need to set up our third web provider. So you can see here, the first thing we need to do is set up our client ID. And this client ID is being stored in an environment variable here in our .env file. So in our files here, if you look, we have a .env.example file, and you can see here we have the variable for our client ID. So I'm going to grab my client ID here, copy it, and then paste it into right here. And again, this client ID is from your thirdweb API key. Then going to rename this file here and just change it to .env. And we'll head back to our _app.tsx file. So that there is setting up our client ID. Next, we're going to need to set up our active chain, and our active chain, we have a variable right up here, and by default, it is going to be set to the Ethereum mainnet, but you're going to change this to the chain that you deployed everything to. In the case for me, I am going to set this to Mumbai because that is the chain that I deployed my contracts to. So we now have our app set up. If we go to our terminal here and run yarn dev, we can see we get our application right over here. This is the templated code that you get when you create an application using thirdweb. You see we have links to our portal, dashboard, and templates, and we have a connect wallet button. Now, if we take a look back at our code editor here, if I head over to the index.tsx file within our pages folder, you can see here, this is our templated code that we get. The connect wallet button is this UI component right here. And again, that UI component is going to get you a fully working connect wallet button out of the box. And you have full customization over this button as well. We have a few tutorial videos that go over how to customize the connect wallet button. We'll drop that down in the description below as well if you want to check out that. You can customize that connect wallet button from the text, the coloring, and some of the icon styles and fonts to match your branding of your Web3 application. But again, this button here, if we click on it, it's going to allow us to connect with MetaMask, Coinbase, and you can see a bunch of different wallets here that we can connect to our application. So if I select MetaMask here, you can see it's connecting. We have our MetaMask wallet connected, and that is my wallet address right over there. I can click on this. This is our connected button here, and I can disconnect from the application. And this UI component, this connect wallet UI component, is what we're going to be using to easily implement smart wallets into our application. thirdweb makes it super easy to do using this connect wallet button here. So coming back to our code editor, I'm going to come back to our underscore app.tsx file, and right under this active chain, I'm going to create a new variable called smart wallet config. And this smart wallet config is going to have the configuration options for a smart wallet, which are two things. We need our factory address, which is going to be the account factory contract address that we deployed. Then we need to state here if we want the gasless transactions to be true or false. So for this example right here, I'm going to I'll set this to false first, and we'll take a look at that in a moment. But I need to provide it with the factory address of our account factory. So let me grab that contract address and let's paste it in right over there. So again, that is our smart wallet config, just needs our factory address, and we have to state if we want gasless transactions to be true or false. Next, we have to add smart wallets into our connect wallet button. So by default, you're not going to get smart wallets added to the connect wallet button. We have to specify that we want it configured. So in our thirdweb provider, we can specify the supported wallets that we want to support within our connect wallet button. And to set up smart wallets, we just say that we want a smart wallet here. And we need to provide the smart wallet with two things. One, we need to provide it with what type of wallet is the EOA wallet going to be. So for this, we'll just say the first one, we'll say a MetaMask wallet. So that will be the first wallet here. And then we need to give it our smart wallet config, which is going to be the smart wallet config that we set up here. Now we can do the same thing here. So let's say we want a smart wallet and we want the option to connect with a Coinbase wallet. So we can say Coinbase wallet and then smart wallet config. And again, to add a smart wallet, we are just providing it one with the EOA wallet type and then our smart wallet config. So the factory address, it should be generating the smart contract wallet or the account from, and we're specifying if we're going to allow gasless transactions or not. So what is this going to look like in our connect wallet button? So if we head back to our application here and we hit connect wallet, you're going to see wallet options and you're going to see MetaMask and Coinbase. Now, these buttons here aren't going to connect your MetaMask or Coinbase wallet to your application, but instead they are going to connect and use your MetaMask or Coinbase as an EOA wallet to then deploy a smart account to connect to your application. So if we select MetaMask here, you can see it connected to MetaMask. It's now connecting to our smart wallet or smart account. And you can see here that we have a different symbol here. And this is going to be, we are connected to a smart wallet. So you can see here that this smart wallet doesn't have any funds in it because it's a new wallet or new account that was generated. And the address here is CDD7. Now I can switch back to my personal wallet, which I can switch to my MetaMask wallet, which is being used as the EOA wallet to that smart wallet. And you can see here, my MetaMask address is B8B2, which is my MetaMask wallet. And you can see here, I have funds and everything still in this wallet because this is my wallet that I normally use. And I can still switch back to my smart wallet here. And we now have access to our smart wallet. Same thing goes if I log out or disconnect my wallet and I hit connect and I connect with Coinbase. We'll get our Coinbase pop-up, we'll hit connect. And you can see here, I'm generated a new smart wallet, which is FF92. And we can switch to our personal wallet, which is a Coinbase wallet. And you can see I have funds and everything in here. And 3560 is my Coinbase wallet. We switch back and we can disconnect. Now we generated two different wallets or smart wallets using my MetaMask and Coinbase wallet. Now, if I actually head back to our account factory contract, so back in my account factory contract in my dashboard here, if I go to account, you can see that there aren't any accounts created. Why does it show no accounts created when we just connected our MetaMask and Coinbase wallet and we saw that we had a smart wallet or a smart account generated for us? With our account factory contracts and your accounts aren't technically deployed until they go through an initial transaction. And what does that mean? It means that with your EOA wallet, you'll be given a deterministic contract address for your account. And this means that your wallet can still receive NFTs, receive native tokens or ERC20 tokens, but the account or the contract hasn't technically been deployed unless you manually deploy it or it gets deployed on its first transaction. Now, this can be beneficial in some ways because as a person who wants to implement smart wallets into your Web3 application, you don't have to pay for the deployment of these wallets, or your user doesn't need to pay for the deployment of these wallets until it is necessary or until they need to go through a transaction. This means that you can create wallets for your users and you can drop them assets into their accounts like ERC20 tokens or NFTs, and their wallet doesn't need to be deployed. You can still check balances of those wallets and everything and see how much of that ERC20 token or NFT they hold in that wallet. And of course, this saves you on the gas needed to deploy these contracts. So how do these accounts get deployed then? So let's actually create something where we can claim an NFT. So coming back to our index.tsx here, under my connect wallet button, I'm going to create a Web3 button. We're going to just call this claim NFT. And our Web3 button, we need to give it a contract address it is going to interact with. And in this case, we have our NFT contract here. And we have to give it the action it is going to do on this contract. So we have our contract here, and we are going to specify it's an ERC4337, and we are going to claim an NFT. So we have to specify the token ID that we're going to claim and the quantity. So the Web3 UI component from thirdweb makes it super easy to interact with your contracts. We provide it with the contract here. And because it is an ERC4337 contract from thirdweb, we can just specify it here and run the claim function, where we provide it with the token ID we're going to claim and the quantity. So right here, if we head back to our application, you can see we have two connect wallet buttons. The second one here is our Web3 button. So let's connect to our MetaMask using that to connect to our smart wallet. There we go. We are connected to our smart wallet and we have this claim NFT here. I'm going to open up my console here so we can see. So right here, if I were to hit claim NFT, remember I have gasless transactions turned off, meaning that we're not going to be using a paymaster to cover the gas of this transaction. So if I hit claim NFT here, you see that I get a signature request that pops up, and this is from my MetaMask because our MetaMask is the EOA wallet or the personal wallet to our smart wallet here. So I still need to sign off and sign that I am approving this transaction here. So if I hit sign, you'll see that we get an error here. Now, this error is because, one, we don't have gas within our smart wallet to pay for this transaction. But right above that, if I zoom in a bit, right above that, you can see that we have a deploying smart wallet via factory. And we can see the estimated cost to deploy this smart wallet, which is right here. And if this transaction had gone through, that is what the gas would have costed in order to deploy the smart contract wallet. Let's actually add some funds into this wallet here. So I'm going to click on here. I'm going to switch, or I'm going to copy my smart wallet address here. I'm going to switch to my personal wallet, and we're going to just send some tokens, some Matic tokens to that wallet here. So I'm going to paste that in here, and we're just going to send 0.15 Matic. So we'll just send that. You can see we get the transaction here. We'll confirm this. And again, the cool thing about the Connect Wallet button with thirdweb is you get all of these features and functionalities out of the box. So there you go. We see that funds were sent successfully. We'll head back here. We'll switch back to our smart wallet. And you can see we now have 0.15 Matic here. So now when I will scroll down here. Now when I claim the NFT, we're going to get the signature request again from our MetaMask. There we go. We'll sign approving the transaction. You can see here again, the cost to deploy the smart wallet is right over here. And now that we have gas within our smart wallet, you can see that our balance has gone down. So it is now 0.148 and our claim has gone through. So let's head back to our contract here, our account factory contract. And you can see we now have one account total, and that is the address ending in CDD7. And if we take a look at our wallet address here, CDD7. So it was deployed again because it went through that initial transaction, and only when going through that transaction or when this wallet executes a transaction will the wallet be deployed. And we can also check in here. If we click on our account here, Again, this brings us to the account dashboard of that account. So we'll see an account here of that contract address CDD7. We'll check the balance here. You can see this is our balance here, which is the 0.148. And you can see we own an NFT in here, which was the one NFT that we just claimed. And that's how easy it is to implement smart wallets into your Web3 application. Now, we're going to show you a few more things that you can do with smart wallets here. So we're going to head back to our code editor here. Now I'm going to change this smart wallet config. I'm going to change the gas list to true. This means that we will be covering the gas for the user transactions. And how this works is through a paymaster, and you will be using thirdweb's paymaster for this. So we head to the settings tab here. And on the left hand side here, you go to account and billing. This is where you can set up your account and your billing for features and services like smart wallets. So if you are going to be using thirdweb's bundler and paymaster, you can set up your credit card info and everything here, and you will be billed the fees that were covered if you have features like gasless transactions and stuff enabled. Makes it super easy to just implement into your Web3 application, and you can just keep track of billing right here through the dashboard. And if you want to keep track of your usage, if you come down to the usage tab here, you can see your infrastructure usage, so your storage pinning. But down here at the bottom under payments, you can see smart wallets, and you can see the total sponsored fees here. So this is going to be for, again, those gasless transactions, and you'll be utilizing thirdweb's paymaster and bundler here. So coming back to our code editor here, if we set gasless to true and come back to our application, I'm going to disconnect from this wallet, and we're going to connect our Coinbase wallet here. Let me just close our console here. And you can see, again, this is a separate wallet address, FF92. Doesn't have any funds in it. It has a 0 balance. And our personal wallet is our Coinbase wallet here. So if I hit claim NFT, what's going to happen here is I'm still going to get the signature request that I'm going to need to sign in my Coinbase wallet. But because I have no funds, so we'll just sign this message. But because I have no funds here, technically this will still go through because we have gasless enabled, meaning that this wallet doesn't need to have funds in order to pay for the gas needed for the transaction. And that could be a feature that you want to enable when trying to onboard people into your application using smart wallets, because again, these wallets are generated with no funds in them, meaning they're not going to be able to cover gas. So with gasless turned on, once the wallet is connected, the wallet is ready to be used. So if we come back to our contract here, we'll see that we now have 2 accounts, and we have the FF92 here, which we go here, and if we click on it, we go to our balance. We have a 0 balance, but we were able to claim that NFT. So again, gasless, all we need to do is toggle it to true in our smart wallet config, and we will then now cover and sponsor those gas fees for our user. And one more feature I want to go over with smart wallets is using that seamless login flow that we spoke about in the last few sections, which combines embedded wallets, which allows a user to generate a wallet via email or social logins. This way, a user doesn't need to come with their own EOA like a MetaMask or Coinbase. They can just sign in with their email. A wallet will be generated for them, and that wallet will then be used as the personal wallet to the smart wallet. This means a user can just come in, sign in with an email, and can start using your application. And with embedded wallets, you won't have to sign any transactions. And with the gasless feature turned on with smart wallets, you don't have to pay for gas. So someone can be brand new to your application, come in, sign in with an email, and start to execute transactions on the blockchain without having the need of any of that other onboarding stuff that you would normally need to go through. So right here, I'm going to, in my supported wallets, create another smart wallet. And for this one, we're going to add it embedded wallet with our smart wallet config. Just add a comma here. So we'll come back to our application. I'm going to sign out of this wallet here. And when we hit connect wallet, you'll see we have an email option here, which we can then sign in with email, or we can sign in with our Google account right here. I'm going to use my email here. So I'm just going to put in my email, hit continue. We'll be sent an OTP to our email. So we'll just verify it here. And once that is verified, again, this will connect us and generate us an embedded wallet. And that embedded wallet will then be used to connect to our smart wallet. So there we go. We now have a new smart wallet generated, this one ending in 2855. We are connected to our smart wallet. If we switch to our personal, you can see it's our email wallet here. This one also has 0 funds because we just created this wallet as well. You can see right here, F419. Now we switch back to our smart wallet. I can claim an NFT. Now, unlike the MetaMask or Coinbase one, I won't have to sign a signature because with embedded wallets, we actually don't need to sign to approve the transaction. And because we have gasless on, we don't need to sign anything or confirm any transactions to pay for the gas. So once this transaction goes through, we would have deployed our smart wallet and that wallet would have already claimed an NFT, again, without having to interact with anything like signing transactions. And there you go. So now we can come back to our accounts again. And we now have 3 accounts, the most recent one being that 2855. If we click in there, you can see that we can see here, we go to our balance. We're going to have a 0 and we have our claimed NFT. And there you have it. We implemented smart wallets or account abstraction into our Web3 application, quick and easy using the Connect Wallet UI component from thirdweb. With thirdweb, we make it very easy to implement these into your applications. All you need to do is deploy an account factory contract, then implement it using our Connect Wallet button, add the supported wallets to your thirdweb provider, and then add the smart wallets with the EOA of your choice along with the smart wallet configs like your factory address and if you want to enable gasless or not. And again, with just those few lines of codes, you're able to implement account abstraction into your Web3 application. Now in the next section, we'll be going over a similar process, but implementing this into a mobile application with React Native and into a game with Unity. Hey everyone, so in this section, we're going to implement smart wallets into a mobile Web3 application using React Native. Now you are going to need an account factory contract, a thirdweb API key as well, and we also deployed a demo NFT collection that we can test claiming on. Now, if you don't have these things, we did set all of this up a couple sessions ago. You can go back and check out the Getting Started section with smart wallets with Connect Wallet, and follow that in order to get your account factory contract, your thirdweb API key, and deploy a demo NFT collection. With all of that, let's jump on the computer and let's build this out in React Native. So I have my terminal open here and we're gonna first create a app. So I'm gonna run npx thirdweb create app. And we're gonna name this here. So I'm gonna name this, smart wallet. We'll just do RN for React Native. Now for framework, we're gonna select React Native. And we're going to choose Expo project for this. And once that's done, we're going to change into our smart wallet React Native, and we're going to open this up in our code editor. Right, and in our code editor, we're going to first go to our .env file here, and you can see this is where we're going to be storing our client ID. So I'm going to erase that. I'm going to get our client ID really quick here. Copy it, paste it in here, save that. Then we're going to head back to our files and we're going to head to the app.tsx file. Now this app.tsx file here, you're going to see your thirdweb provider and we need to set up a few things here. First, the active chain, you're going to make sure that this chain here is the chain that you deployed your contracts to. So in this case, we had deployed to the Mumbai testnet, so we're going to leave that there at Mumbai. And we have this line commented out here. You can see we have to uncomment this line after we set the client ID in the .env file, which we already have. So we will uncomment that. And you can see here our client ID is just set to our client ID that we had set in our .env file. Just like we did in the React, we have supported wallets here, which we are going to add our smart wallets to. But before we do that, let's run this on a iOS simulator here. So I'm going to open up my terminal and I'm just going to run yarn iOS. And there you go. We are now running our React Native app on our iOS simulator. You can see we just have a title here and a Connect Wallet button. And this is going to be the Connect Wallet button, similar to our React web app, that we're going to be able to configure our smart wallets with. Now, I'm going to come back to my code editor here. We'll just drop down this terminal here. And very similar to how we set up our smart wallets with React, we're going to Come right over here. We're going to create a variable called our smart wallet config. And this smart wallet config is going to have our factory address. And we're going to set if we want gasless enabled or not. Right now, for this, we are going to just put true here. And we're going to grab our factory address. Grab that. Paste that in here. And just like we did in React, under our third web provider, our supported wallets here, we can provide the wallets that we want to support with our connect wallet button. So the first one we're going to do is we're going to do smart wallet. And smart wallet, again, takes two things. First is what wallet do we want to provide as the EOA wallet? So we can do something like a MetaMask wallet again. And then we provide these smart wallet configs. We can do the same thing for Coinbase wallet. So we'll do smart wallet. We'll do Coinbase wallet and smart wallet config. Now I'm going to do one more here, and we're going to do smart wallet here. And I'm going to do this with the local wallet. And what local wallet is, it's a wallet that we can generate for a user locally on the device that they are using. And this is a great way we kind of use it as a continue with guest method because, again, you don't need to provide any credentials. Like embedded wallet, you provide your credentials of email or social login. With local wallet, we can just generate a wallet for you. And it's kind of a use case where we just want to generate and someone wants to continue using the application. So if we do local wallet here with smart wallet, and I'll explain in a bit why we're going to do local wallet. But we have these three wallets, MetaMask, Coinbase, and local wallet set up with our smart wallet config. Again, we gave it our factory address for our account factory address contract, and we have gasless enabled. So if I come back to the simulator here and I hit connect wallet, you don't see anything change. We still have MetaMask, we still have Coinbase, and we still have continue as guests. But again, remember, when we click on this, it's not going to connect directly to a MetaMask wallet or Coinbase wallet or our local wallet. It is going to connect with those wallets, but then connect to a smart wallet on top of that. Now, because we're using an iOS simulator, we won't be able to use MetaMask or Coinbase because we can't install MetaMask or Coinbase app onto our simulator, which is why I did local wallet here. And this is just to show you that how easy it is to set up smart wallets. Now, if you're running this on an actual iOS device, you'll be able to use MetaMask or Coinbase. And with the connection process, you'll be brought to your MetaMask or Coinbase app on your mobile device. But if we hit continue a guest, you can see here it's connecting with our local wallet first, and then it is going to connect to our smart wallet. So again, we have our smart wallet here. You can see we are connected to a smart wallet. We have a new wallet address of EE05. It doesn't have any funds in it. We can switch to our personal wallet, which in this case is our local wallet. This was a wallet that was just generated for us on this device. You can see this is a temporary guest wallet, and we have to download the backup if we don't want to lose access to it. And that's essentially what local wallet is. Now we can just switch back to smart wallet here. Again, we have quickly and easily set up smart wallets on top of our Web3 mobile application with React Native. And just to test this out, we will test out a claim again. So we're going to come down to this app inner, and under our connect wallet button, we'll create a Web3 button, which will be called claim NFT. And we can, again, provide our contract address for our contract we're going to claim from, and then the action. And just like our other claim, we're going to claim a contract that we can specify because this is a third web ERC4337. We'll do the claim, and we're going to claim token ID 1, and we're going to claim a quantity of 1. Now let me get my NFT contract address here. And again, this is the contract address that we deployed in the getting started part of this section. So just like that, we added a button in our mobile application to claim an NFT from that NFT smart contract. So if we come back to our app here, we now have this claim NFT button. If we take a look also at our account factory dashboard, we have our 3 accounts that we created last time, which is our MetaMask, Coinbase, and embedded wallet. You can see we don't have our EE05. We have our CDD7, FF92, and 2855. And if you remember from the last section, we went over that a account, although generated for you when we connect to a smart wallet, is not deployed yet until this wallet is either manually deployed or goes through a transaction. So we hit claim NFT here. Now we have a local wallet and we have gasless enabled on the smart wallet side. So we're not going to have to sign any transactions. We don't need to pay for any gas. This is just going to claim an NFT for us. And during that initial claim, because this is the wallet's first transaction, it will then deploy its account contract, which we will see over here, and we'll be able to view the NFTs that it then holds. So if we come back, we give it a moment. There we go. We have 4 accounts. You can see we got EE05 added. If we click on that, it brings us to the account contract. And here we can check the balance of the account. Of course, we don't have anything in this wallet because, again, it's a brand new wallet that was generated. But you can see here we have our NFT that we own, which is that NFT contract that we deployed earlier. So that is how quick and simple it is to add and implement smart wallets into your Web3 mobile application. Now, the great thing with this is if you're using something like a local wallet or embedded wallet with signless transactions, your user never needs to leave your mobile app to confirm transactions. Unlike using a MetaMask wallet or Coinbase wallet, every time a transaction needs to be signed, a user has to leave your app, go into their wallet app, sign that transaction, and then jump back into your application. So you can create a very good and seamless user experience when combining smart wallet with gasless transactions paired up with something like a local wallet or a embedded wallet. But that does it for this section with implementing smart wallets into your Web3 mobile application with React Native. In the next section, we're going to go over our last implementation, which is going to be implementing smart wallets into your very own Web3 games using Unity. But again, all the timestamps are down below in the description. So if you need to skip around or rewatch any sections, you can check that out. But with that being said, let's jump on to the next section. Hey everyone, so in this section, we're going to continue with implementing smart wallets into a Web3 application. In this one, we are going to actually be implementing it into a Web3 game built with Unity using our Unity SDK. Now again, if you haven't watched the getting started part of this section, we deployed an account factory contract, we got our own thirdweb API key, and we deployed a demo NFT smart contract that we'll be able to test and claim. So if you haven't done that yet, you can check out the timestamps down in the description, head back to the getting started section and do those steps because we aren't going to cover that within this section. But with that being said, let's jump on the computer here, set up our very own Unity game and implement our smart wallets into it. So on my computer here, I am on our Unity SDK release page. We'll add this down in the description below, or you can head on to our portal and docs, and under the Unity section, there is a link that will bring you here. Now, as of recording this video, our latest version of the Unity SDK is 3.3.1. And what I'm going to do here is just download the thirdweb Unity SDK here. And once we have it downloaded, we're going to head on over to our Unity Hub. And in our Unity Hub, I'm going to create a new project. So I'm going to click New Project in the top right here. And we're going to create a 3D Core project. And I'm going to name this here Smart Wallet Unity. And we're going to create this project. So we'll wait for our project to be created and our Unity editor to open up. And once your Unity editor is open, let me just open these a little bit more here. You can see in our project folders, we only have our assets and our scene here, which is our sample scene right here. What I'm going to do is in the top bar, I'm going to come over to our assets and we're going to import a package and import a custom package. And we're going to select our thirdweb Unity SDK. We're going to hit open. It'll bring us up our import window here. We're going to make sure everything's checked off and we're going to hit import. And once that completes in our assets folder, now you'll see we have a few more folders here, including our thirdweb folder. And the main important prefab that we're going to use from our thirdweb folder here is in there under the core folder, under prefabs. We have a prefab here called the thirdweb manager. Now I'm going to drag that prefab into our sample scene here. And I'm going to just drag out my inspector here. And the thirdweb manager is the main prefab that you're going to use to configure the thirdweb SDK. And from here, we'll be able to access this instance of this thirdweb manager within our code. So for general settings here, we're going to set the active chain just like we did in React and React Native. So I used the Mumbai here. Now below this, we're going to set our client ID. So I'm going to grab my client ID. Come here, paste that in, and then that's all we need to do here in our general settings. I'm going to come down to Smart Wallet options, and in Smart Wallet options, we need to provide it with our account factory contract address. So paste that in, and we can then check off if we want to enable gasless transactions or not. So I'm going to check that off so we can enable gasless transactions. And that does it for the setup that we need to do for setting up the general settings for our thirdweb SDK and our smart wallet here. So what we're going to do here is in our sample scene, let me just open this up a little. I'm going to right click and add a UI component, and I'm going to add a canvas. And I'm just going to call this menu here, and we'll enlarge our inspector. And on that menu, I'm going to select the canvas scaler, and I'm going to scale with screen size, and we're going to make this 1920 by 1080. So if we come to our menu here and I run this, you can see this is our game here. We don't have anything in it yet though, because we didn't add anything. But we know that we have our menu screen right here. So what I'm going to do in the menu here is in our project folder, we are going to go into the examples folder, and we're going to go under prefabs. And here we have a prefab for a connect wallet button. So you can see up here in the inspector, we have prefab connect wallet, and I can just click and drag that into our menu. So we have our connect wallet button here. Let me just shift this around really quick. All right, so we have it facing there. So you can see we get a connect wallet button added into the top right of our application. So if I were to just run this here in our app, we can just make this a little smaller so we can make our screen a little bigger here. Again, we have a connect wallet button. It opens up a connect wallet component similar to what we have in React and React Native. Now, we're going to set up smart wallets here. As you can see, we have some smart wallets set up here. But I'm going to come back here, and let's open up our inspector, and let's go into our connect wallet prefab. So let me stop playing this. So if we select our connect wallet prefab here, we have a few things that we can set up. So we can choose the supported wallets here. So let's actually just remove all of these wallets and only support smart wallet, just so we can take a look at that. So we only have smart wallet here. You can also select here the personal wallet option for our smart wallet. So similar to how we select the EOA wallet for our smart wallet in React and React Native, here in this dropdown, we can select the same thing here. Now I'm going to use local wallet here, just like how we did with our React Native, just because we're just going to be running this game right here in our simulator, and we won't have a MetaMask wallet or like a Coinbase wallet to connect to. And with that being said, just using our connect wallet prefab here, you can just have smart wallet and select the EOA wallet of your choice here. And that's how simple it is to set up smart wallets. So if we run this application again, let me just drop this down so we can make the screen a little bit bigger. I run this. You can see we can have a connect wallet button. We have smart wallet. When I select that, it generates the local wallet and then connects us to the smart wallet here. So right here, we are connected. And if I select this, you can see we have a wallet with Zeromatic, and we have a wallet address of FF26, which is our smart wallet here. Now we can create a claim here really quick. Let's stop playing this, and we can test it out and deploy our wallet. So in this menu here, I'm going to create a new UI component. We're going to create a button. We'll leave it there in the middle. And if I drop down button here and change the text, I can just change this to claim NFT. And we're going to write a script here to claim, to make this button claim an NFT. So we're going to go over this really quick. And I'm just going to, on my menu, add a component. We're going to add a new script, and we're just going to call this menu script. Once that's created, we're going to right click and edit our script. That will open up in our code editor. So in here, I'm going to say using thirdweb, and we're going to delete this code here. And we're going to just create a new function called claim NFT. And the first thing we need to do in our claim is get an instance of our SDK. So it's going to be our thirdweb SDK, which is going to equal, we'll just name it SDK. And to get an instance of our SDK, we can just get the thirdweb manager here. we can get .instance and then .sdk. That will get us an instance of our SDK. Then we can get our contract, which we'll just name contract. And to get this, we do SDK.get contract, and we are going to get the contract of our NFT. So let me just grab that really quick. Then we'll run the function to claim our NFT. So we'll just create a variable called data here, and this is going to, we'll make this a public async void. So we're going to await, and then we're going to do contract. We can then specify that it is an ERC4337. And we're going to then call the claim function here, which will specify the token ID and the quantity that we want to claim. So we'll save that. This here will run our claim function and claim an NFT to our wallet. So we can just then do a debug log, and then we'll just say claim NFT and give it the data here. So we'll return back to our Unity editor here. And oh, it looks like we have a few get contract, and we need to give it a string for argument 1. Okay, so coming back to our code editor here, it looks like yeah, get contract is supposed to be a capital G, and we need to pass it a string of token ID and the number for the quantity. So we come back here. I think that should fix everything. There we go. Now we just need to apply that function to the claim button. So we come back to our button here. We scroll down on this on click. We can hit add, and we just need to drag our menu here into here, and then we can select our function from our menu script, which is claim NFT. So right over here, let's shrink this down again so we can see our screen. So if we run this, we can connect to our smart wallet. So once we are connected, you can see here we are connected. We had gas list turned on. So this is wallet FF26. And then we can hit claim NFT, and this should claim us that one NFT, which is going to be that ERC4337 demo contract that we deployed. So we'll get a moment. Looks like everything is going through here. And there you go. We have claimed, we have a transaction successful. If we look at our console log here, transaction successful, and we have the transaction hash here as well. So we come back to our contract, and we come back to our account factory. We now have 5 accounts. Again, the first 3 was our MetaMask Coinbase wallet and embedded wallet. This was our smart wallet with local wallet on React Native, and this is our smart wallet with local wallet on Unity. You can see here FF26. So if we click on that, we can take a look at the account contract, and we can take a look at the balance here. And there we go. We have FF26, and we now own that one NFT. And there you have it. We implemented smart wallets into multiple different platforms. First, we implemented it into our web applications with React, into our mobile applications with React Native, and just in this last section, we implemented it into our Web3 game using Unity. Now we implemented smart wallets into these different platforms using the Connect Wallet UI component, which again makes it super easy to build a onboarding flow for your users to, one, either connect a wallet of their choice, or to implement smart wallets and allow a user to choose the wallet they want as their EOA. And that does it for this section. Now in the next section, we're still going to be implementing smart wallets into our Web3 applications, but we're going to be creating our own custom flow. So instead of using the Connect Wallet UI component from thirdweb, you can actually access all the low-level hooks that you want using our wallet SDK, and you can create and implement your very own Connect flow and use smart wallets at the same time. So in the next section, we're going to be building a flow which uses embedded wallets with smart wallets again, but instead of using our Connect Wallet button, we'll create our very own login card where a user can input their email and then access their smart wallet. Again, all the timestamps for all these different sections will be down in the description below. So if you want to rewatch some of the sections on how to implement smart wallets using the Connect Wallet UI component, you can check out those timestamps below. With that being said, let's move on to the next section and create our own custom Connect flow. Hey everyone, and welcome to the final section of our account abstraction course. And in this last section, we're going to be creating our very own custom account factory contract and building a unique custom flow that takes into account some of those custom features that we're going to add into our smart contract. And the custom connect flow that we're going to be building is allowing a user to log in with a username and a password. So an overview of what we're going to be covering in this section, we'll first demo out the login and connect flow that we're going to be building. We'll then take a dive and see how this flow actually works behind the scenes, break it down so that we have a better understanding of what we're going to be building. We'll then create our very own custom account factory contract, and then we'll build out our application demo where we build our own custom flow. So all that being said, let's jump on the computer here. Let's take a look at the demo we'll be building. So right here on my computer, you can see we have a login card here. This is just our custom account abstraction login where we'll be able to log in with a username and password. So when I log in here, you can see that I have a username and password input field here. So I can put in a username here and we'll just say thirdweb. I can create any password that I want. And when I hit login, we're going to check the username. We're going to see if the username exists or not. So this username does not exist. So what it is doing, it is now creating a local wallet and it is uploading the metadata of that local wallet to IPFS, and it's encrypted via the password that we chose. That way, when we want to connected to the same account, we can then download the local wallet from IPFS, decrypt it with our password, and then connect to our smart wallet. Now, because this is a new wallet, it is taking some time to create the local wallet and upload all of that metadata to IPFS. But once it is connected, you can see here that we can actually pull the username that we signed in with. This is the wallet address. I'm just displaying the smart wallet address here, and we can claim NFTs and we can interact with our Web3 application. Now, I do have gasless turned on, and because this is a local wallet, I don't have to sign in order to interact with a contract. So you can see here, we're going to claim an NFT. It's claiming an NFT. We have the total showing down here because this is a new wallet that generated. It's not going to have any NFTs. But once we claim here, we'll be able to see that we have one. There we go. We have one NFT. Now I'm going to go back here and I'm going to log in with the account that I created before. And what you'll see when we log in, they'll check for a username. Username does exist. So what it's doing now, it is now connecting to our local wallet using the password to decrypt it, and then using that to connect to our smart wallet. And you can see here, I pulled down this account here and I have already an NFT in here. So this is an example again of how we can create these unique user experiences using smart wallets and how we can create our very own custom account factory contract to accomplish this. Now, before we jump into creating our contracts and our demo application here, let's take a look and break down what's actually happening so we get a better understanding of how this is built. So over here, you can see this is a connection flow chart of how everything works behind the scenes. So over here on the left, a user inputs their username and password. We're then going to check our account factory contract if that username exists. Let's say, for example, the username does not exist. What we're going to do is then generate a local wallet. And again, a local wallet is a wallet that we can create for the user locally on the device that they are using. Now, normally local wallet can be used as like a continue as guest like type of wallet because we can instantly generate it and a user doesn't need to worry about things and they can still interact with some parts of your Web3 application. Now, the downside of local wallet is it is again stored locally on that device. So if I were to access a site and get a local wallet generated for me on my computer, and then I went to that same site on, say, something like my phone, I wouldn't be able to access that same local wallet unless I exported that wallet to something like a JSON and imported it into my phone and imported that wallet into that application. I would then be able to access the same wallet. So what this flow allows us to do is actually we're going to upload the encrypted JSON file to IPFS. So when there is no account and we don't see an account registered to that username, we're going to generate a local wallet. we can encrypt that wallet with a password, which we're going to use the password that the user provides in the login. We will then upload that encrypted JSON to IPFS. And that way, when we connect back to our application and we see that our account does exist, we can download that encrypted JSON file, decrypt it, and then use it to connect to our smart wallet. So again, that is encrypted. It's uploaded to IPFS. We'll then also deploy a account contract, and we'll call a function that we are going to create called register that registers the username and the IPFS of that encrypted wallet and registers it to the account. And then after that, we'll then use that local wallet to connect to that account. And we had now connected our smart wallet. So going back to the beginning, if we put in a username and password, we see that the account does exist. We get the IPFS URI that we got from over here when we uploaded it to IPFS. We'll then download it, decrypt it with the password that was provided with the user. Then we'll import that decrypted local wallet and use that to connect to our smart wallet again. And that way we'll be able to access the same account. And this works on any device because again, we're downloading the same local wallet that we have uploaded to IPFS that we can access from anywhere. And what I do want to mention before we continue on in this tutorial and this build is that this is a proof of concept. This is something that we created to showcase and show an example of how you can customize your own account factory contract. As you have probably noticed while going through the flow, there are some holes that you can poke within this connect flow, like the password being set and not being able to change it. Although these functions and features can be added on, we're not going to go into that in this demo build. But now that we have a better understanding of how the connection flow works, let's create our own custom account factory contract and build this out. So I have my terminal open here and we're going to create our very own contract. So I'm going to run npx thirdweb create contract. And we're going to create our own custom contract here. So I'm going to call this AA course custom contract. And we're going to use Forge for this. And we're going to name our new contract. Now we're going to be creating two custom account contracts. We're going to create a custom account factory contract. And then we're also going to have to create a custom account contract. So I'm just going to name this here the custom account factory. And we're going to use an empty contract here. And we're going to change into our AA course custom contract. Open this up in our code editor. And in our code editor here, I'm going to head into our source folder and find our contract here. Now I'm going to rename this here and make sure and rename this one our custom account factory. I'm also going to create a new file and I'm going to name this a custom account.so. So we'll have our custom account factory and our custom account. And I'll just copy this and paste it into the custom account as well. So we're first going to start off in our custom account factory contract. And over here, we're going to name this contract again, custom account factory. And this is going to be a base account factory. We're just going to be adding our own functionality to it. And what I'm also going to do here is import our base account factories. Let me just grab that here. So there we go. We're going to import our base account factory from our thirdweb contracts. And I'm also going to import our custom account, which is going to be this contract here. So coming to our custom account, I'm going to do the same thing. This is going to be our custom account, which is an account. And we're going to import our custom account factory.so. And we're going to import thirdweb's account contract as well. So there we go. We're going to import account from thirdweb and our custom account factory, which is our account factory here. So in our custom account, we're going to set up first our constructor. And now we can, if we look at our docs here, and we'll link this documentation down in the description below. But in our Solidity docs here, if we go to non-upgradable account factory and we go to the accounts here, we can see that we can again import this account Solidity. and we can inherit all the base account contracts. So if we scroll down here, we can see usage. We'll need to copy our constructor here because we'll need to use this within our contract. So if I come back to my code editor here, I'm going to just erase this constructor, paste in this constructor here for our account. And then if we come back to our docs and we go to the account factory section, we can see here that we need to set up our constructor here. So we have our constructor here. Let's copy that. We'll come to our custom account factory. We'll take away this constructor here. Now the account factory here, we're going to be calling the constructor of our base account factory. So we can go base account factory. And for our base account factory, if we take a look at this here, we find our constructor. We need to give it the address of our account implementation and the address of our entry point. So in there, we'll get the address of a new custom account, which is going to be our custom account here, which takes the entry point and the address of our factory. So we'll take the entrance point and the address of this contract, which is our account factory contract, and then we will provide it with the address of our entry point. We take a look back at our docs here. We do also need to initialize our account. So we have to copy this right over here. Come back to our code editor. Right below the constructor, we're going to paste in our function to initialize account. Now, this isn't going to be account. This is going to be a custom account. And then for the initialize, we have the account, which is going to be the account contract address. And then we have the admin, which is going to be the wallet address of the EOA wallet. And bytes here, we can provide it with some data if we have some more data that we need to pass through to our accounts when they're created, which we can use to create other custom features. But we're not going to be providing it any data here, so we'll just provide this here with an empty string. Now at the top here, we're going to create an event. This event is going to be emitted when we register a new username to our contract. So we're going to create an event here called registered. And what this is going to emit is a string, which is going to be the username that was registered, along with an address, which is going to be the account that it was registered to. So the contract address of the account contract that was deployed will attach a username to that account. We'll then create a mapping here that is going to map a string, which is the username, to an account, which is going to be an address. This is going to be a public mapping that we can access, and we're going to call this account of username. So this is how we'll be able to find the contract, the account contract that is associated to the username. And then what we're going to do is create our very own function for our account factory contract. Now this function is going to be called when we register, so we'll call it onRegistered. When we register a username to a account, we'll need the string here, which will be the call data, and we'll call this username. And this function is going to be an external function. And what we're going to be doing here is getting the address of the account, which is going to be the sender, because the account contract will be the one that executes this function. We're going to require, on this account factory contract, check is registered. And what we're going to check is if the account is registered. And again, we're going to require that this is a registered account. That means that this account was created from this account factory contract. Then we're also going to require that the username is available. So we're going to make sure that the username does not have a contract address or an account contract already assigned to it. If it does, it means the username is already taken, therefore we can't register it. And if both of those requirements are made, we again are checking that this is an account of this account factory and that the username is available. We'll then set the account of the username that was submitted to the account. And we'll then emit that it was registered and the username was registered to that account. And that there is our account factory contract. Now we're going to also make some changes to our custom account, which require us to create that register function to register the username and register it together with the metadata of the encrypted JSON or local wallet that we are going to create and upload to IPFS. So in our custom account factory here, we're going to create a function called register. And what we're going to take for this function is a string. And the first string is going to be our call data of our username. The second one is going to be a string of the call data of our metadata URI that we have uploaded to IPFS. This is going to be an external function. And here we're going to require that the sender of this is itself, because only the contract or the account contract should be able to register its own username. And we'll just say only the account can register itself. Then what we're going to do is on our custom account factory of our factory, we are going to call the onRegistered function with the username. And we are then going to set up contract URI to the metadata URI. So again, we are registering the username and connecting that username and registering it with the metadata that we upload to IPFS of our encrypted local wallet. And we just need a comma here. So this is our custom account factory contract, again, allowing us to register a username and password. And using the flow that we went through with encrypting and decrypting a local wallet and storing it in IPFS, we're able to upload that encrypted JSON to IPFS and bring it down and decrypt it whenever we want to connect our wallet utilizing the password. And the username is what we're using to basically find what wallet we need to download if there is one available. And if not, we are assigning the metadata of that wallet to a new username if it didn't already exist. So now with both of the custom account and custom account factory contracts created, let's now deploy this. So I'm going to open up my terminal here and I'm going to run npx thirdweb deploy. And we're going to, it's going to detect our project and compile it. And I'm going to select both our custom account and our custom account factory. And we're going to hit enter to deploy them. You can see here it's uploading our contract data to IPFS. And it should open up a new browser window for us to deploy our contract. And there you go, it opened up our new window here. We're going to see both our contracts here. Now we only need to deploy the custom account factory. So we'll select that. And you can see here we need to provide the contract parameter of our entry point. Now this is going to be the entry point contract for ERC4337. We'll provide this down in the description below if you want to copy it. And then you need to select the network or chain that you want to deploy your account factory to. Now, through all the other sections here, we've been deploying to Mumbai, and I'll be deploying it to Mumbai again and utilizing our NFT demo collections and everything that we've been using in the previous sections. So I'm going to deploy this to the Mumbai network. Going to confirm that transaction. I'm going to sign this transaction here. And once that's been deployed, we now have our custom account factory contract. So I'm going to copy this contract address on the side here and paste this here for us to use again. Now, one thing I do want to note before we continue building out our application is I do want to note the version of the account factory contract that we are using to create this custom account factory contract. Now, right over here, you can see the current version that we are using is 1.4. Now, the only reason I mention this is because we are continuously upgrading and updating the functionality of our account factory contracts, and some of the implementations that we are doing right now may change or differ slightly depending on the version that you're using. So just a heads up, wanted to point that out, that in this video as of recording, we are currently using the account factory contract on version 1.4. So now with our custom account factory contract deployed, let's start building out our custom login or connect flow utilizing the username and password. So I'm going to open up my terminal here. I'm going to clear this out. And we're going to create our new project and run npx thirdweb create app. And we're going to name this here. We'll name this custom AA connect flow. We're going to use Next.js and TypeScript for this project. And once that's done, we'll change into our custom AA connect flow project and open that up in our code editor. And just like the other projects that we've done in the previous sections, we're going to set up our application here. So in our pages folder, we're going to go to the _app.tsx file first. We're going to change this active chain here to the chain that you've deployed your contracts to. In my case, I'm going to be changing that to Mumbai. And the other thing in our third web provider here that we need to set up is our client ID. So I'm going to head over to the .env.example file, grab our client ID, and we've covered this in the previous section. So if you skipped over that section or you need to go back and watch it, we have, again, all the timestamps down in the description below. I'm just going to rename this here to .env, and we can close that out. So now that we have that set, let's take a look at that demo application again. So right over here, we're gonna just create our custom login here with our login modal that takes in our username and password. So I'm gonna come over to the index.tsx file that's in the pages folder, and I'm going to delete some of this stuff here. So I'm gonna, everything within this div with the styles container, I'm going to take out. Let me just take this out here. And the next thing I'm going to do is actually copy and paste in some of the styles that I've created. Now, I'm not going to go over the styling in this video, but you can check out the repo links down in the description below if you want to copy my same styling. This is just so that the application looks nice as we go through this tutorial. And in here, I'm going to then create a well, actually, let's get rid of this import, and we'll get rid of the connect wallet import too, because we're not going to be using that here. And for this, we're going to create first a state variable here for is modal open, which we're going to use state, which I'm going to import here. And this is going to let us know if our login modal is open or not. And right here in these divs, I'm going to say if the login modal is not open, we're going to create a div here with the class name of styles.card. And in that div, we're going to have a h1 here, and we'll just say custom AA login. And this is going to have a style here of, we'll just say margin bottom of 0 pixels. Then below that, we'll just have some description here saying login with a username and password. Below that, we will create a button, and this is going to be our login button. And this login button will have a class name of styles.button, and this on click here for this button. So on click is just going to set the modal to open. And what we'll do is open up our modal. So if we take a look at, oh, actually, let's run our application here. So let's open up our terminal, run yarn dev, open this up. And right over here, we have our login modal. We can open it, but it doesn't open to anything because we haven't set that yet. So back in our code editor here, let me just drop this down. We're going to, in our file directory, create a new folder here called components and build our login form. So components, and in here, I'm going to create a new file called login.tsx. And for this login form or card that we're going to create a type of login props here. And this is going to have is open, which is going to be a boolean. And then we have a on close, export, and create a functional React component. And in here, we're going to create a few different state variables that we're going to need for our form. So the first state variable is going to be the username. We'll import use state here. The second state variable is going to be our password. The next one is going to be our signer that we get once we have connected our smart wallet. So we're going to set signer, and this is going to use state, and we're going to specify any here and set it to null. And then we're going to create one for is loading. Then we're going to create one for our loading status so we can display where our connection is at. And then finally, we'll create one for an error. So if there is an error, we can display that as well. So again, we have state variables for our username and password, for our signer, for when we connect our smart wallet. We have our is loading and our loading status, and we have our error. Now, if it is open is false, we're going to return no. And then we're going to also create a handle outside click that will just, if there's any event outside of our div element, it will close out our card or our login card that we create. So now, depending on the state of our login, we're going to display a certain card. So we have, if we have a username and we have a signer, we can display a connected state of our card. If it is loading, we'll display a loading state of our card. If there is an error, we'll display an error state of our card. And other than that, we will display our login card with our inputs and forms for our login. So we'll do our loading first. So once we have signed in and we're determining if there is a username registered, if we can retrieve our encrypted metadata, or if we have to download our encrypted metadata. For that loading here, we're going to create a div. This is going to have a class name of styles. Let's import styles here. So that loading is going to have a class name of styles.card. And in there, we're going to have another div. And within that div, we will have just some text here that is going to display our loading status. And we'll just create this div, and it'll have a style of a width of 440 pixels. So it's just going to have a card that shows the loading status. So the status of and where we are within the process of connecting. Now for our error, we'll do that one next. We'll create a div. This is going to again have the class name of styles.card. And within here, we're going to just have some text that says error. And below that, we'll have a button, and that button will just say try again. And what this button is going to do is just set the error. So we'll just say on click. We're just going to set error back to some empty string tags again, to an empty string again. And we'll give this a class name of styles.button. And then next we'll build our login form. So we're going to create a div here. And then for this div for our login form, we're going to give it a class name of styles.login background. And we're going to give it the on click of handle outside click. So if we click on this background here, it'll also close our modal. Then we're going to create a div within this. This will have the class name of styles.login card. In there, we'll create another div. This will have the class name of styles.login header. And we're going to create a H1 here called AA custom login. We'll also have a button here. This will be just an X. And this is going to be a on click. And this will just close the modal. Now below that header, we'll create another div. This will be our form. So we'll give it the class name of styles.login form. And we're going to have two inputs. So the first input is going to be of type text. It's going to have the placeholder of username, the value of our username, and on change, we will set the username to whatever's in our input. The next input is going to be for our password. And this is going to have our placeholder of password, our value of password, and on change, it will set the password to our input value. And then below that, we'll have a button. And that button will be our login button that we will have a on click for, which will then have a function that we will create that we'll just create it here, connect wallet. So we'll create a connect wallet function that when we hit the login, it's going to take in our username and password and go through our connect flow. So let's come up here and let's create that function. So we're going to create a connect wallet function that we're not going to do anything here yet because we need to create that function and that flow for logging in and connecting to our smart wallet. So in my files here, I'm going to create a new folder called lib, and I'm going to create a new file in it. This file I'm going to name constants.ts. And in that constants.ts, I'm going to create a few constants that we're going to use within our application. So the first one is going to be our thirdweb API key. The next constant is going to be our chain, and we're going to set this to Mumbai, and we're going to import Mumbai from @thirdwebdev/chains. Next, we're going to have our factory address, so our const factory address, and we're going to get our NFT collection as well. So let me get our variables here. So I have our client ID, we have our factory address, and we have the contract address for our NFT collection. So there we go. Those are going to be our constants. And again, this is just ones that we'll use throughout our application. So coming back here in my lib, I'm also going to create a new file called wallets.ts. And in this wallets.ts is where we'll start to create our function to connect to our smart wallet. Now, the first function we're going to create is generating a smart wallet. So we'll do export function and we'll do create smart wallet. Now, this create smart wallet is going to create us a smart wallet. And what we're going to do is create a variable called smart wallet. And this is going to equal a new smart wallet. And we'll give it some of the options here, which is going to be the chain that we are going to connect to, which is going to be the chain that we stored in our constants. We're going to provide it with our factory address, which is going to be our factory address that we stored in our constants. We're going to set gas list here. We're going to set gas list to true. And then we're going to provide it with our client ID, which is going to be our thirdweb API key. Or we'll provide it with an empty string if we don't have it. And after that, we are then going to just return our smart wallet that we created with this function. Next function we're going to create is going to be a function to get the wallet address for the user. So we're going to use that mapping that we created in our smart contract, and we're going to provide it with a username and basically get the account contract that is associated to the username. So we're going to export here an async function that's going to be called get wallet address for user. And we have to provide our SDK, which is going to be our thirdweb SDK. And we have to provide our username, which is going to be a string. This will give us a promise of string here. And what we're going to do for our function is first get our factory contract. So we're going to await our SDK and get contract, providing it with our factory address. We're then going to get our smart wallet address. So smart wallet address, which is going to be a string. And we are going to await our factory. And we're going to call a function from our account factory. And that function is that mapping, which was account of username. And we're going to provide it the argument of our username. And what that will do is return us our smart wallet address associated to that username. Then the next function we're going to create is our connect to smart wallet function. Now this is going to follow the flow that we went over in that flow chart in the beginning of this section, where depending if the username exists or doesn't exist, we'll either be downloading or uploading our encrypted metadata to IPFS or downloading it and decrypting it to connect to our smart wallet. So we're going to here create export async function. This is going to be called connect to smart wallet, which is going to be taking in our username, which is going to be a string, our password, which is also going to be a string, and then we'll set the status callback here, and that way we can provide the loading status for where we are within our connection flow. This will provide us with a promise of smart wallet, and we'll create our function here. So first, we will set the status callback to checking username, because we again are going to check if the username exists. And when we're checking username, we first need to get an instance of our SDK, which we are going to get a new thirdweb SDK here. We're going to provide it with a chain, and then this should be our client IDs, our options here. There you go. So thirdweb SDK, we're going to say SDK is going to equal new thirdweb SDK, which we are going to provide it with our chain and then our client ID. And we'll get rid of these curly brackets here. There we go. Once we have our SDK, we can then get our smart wallet address from the function that we created above. So we are going to await our get wallet address for user, providing it with our SDK right here and the username. So again, that is going to call this function here to get our smart wallet address. So if that wallet address does exist, we'll be getting that and storing our smart wallet address there. We're then going to check if that wallet address is deployed. And we're going to check this by awaiting, and we're going to use the is contract deployed hook here. And we're going to give it our smart wallet address, which is going to be our account contract. And then we need to provide it with our provider. So we can do sdk.getProvider here. And this is going to check if our smart wallet or account contract has been deployed. Because if it isn't deployed, it means that we need to create a new one for the user. And if it is deployed, it means that we can again pull down the encrypted metadata for our user for them to access their smart wallet. So we'll get our smart wallet, which will create a new smart wallet. We'll also get our personal wallet, which is going to be a new local wallet. Now again, we're going to check if that contract is deployed or not. So we'll start with if our wallet is not deployed. So if our wallet is not deployed, we're going to set the status callback to a new username. So we're going to generate personal wallet. So what we're going to do is await, and our personal wallet, which is going to be our local wallet, we are going to generate one for the user. So we're going to generate. Then we are going to create an encrypted wallet, which is going to, we'll await, it's going to be our personal wallet. And we are going to export it. And for our export, we will provide it with the strategy of encrypted JSON. And we'll encrypt it with the password, which is going to be the password. We're then going to await our smart wallet and connect that smart wallet and set the personal wallet to the personal wallet, which is the local wallet that we generated. We'll then set the status callback here to uploading and registering username. Because what we'll do next is await and then get our smart wallet, and we'll have to deploy our smart wallet. So if we remember from the previous sections, a smart wallet isn't deployed until it goes through its first transaction, or we deploy it manually. So over here, because we want the contract to be deployed, we're going to deploy it manually upon the first time that the username is being created and we're creating this account for the user. We're then going to get our contract, which is going to be our account contract. And we can get that by getting our smart wallet dot get account contract. We'll then create our encrypted wallet URI, which is what we're going to upload to IPFS. So we're going to await stk.storage.upload, and we are going to upload a name, which is going to be our username, and our encrypted wallet. And URI is going to be our encrypted wallet URI, which we are then going to register to our username on our contract. So we're going to await our contract, and we're going to call the register function. And the register function, again, remember, registers our username to that wallet, which we uploaded into this encrypted wallet URI. After that, we will then return our smart wallet. So again, this is the flow that we'll take if this is a new username and the username didn't exist. Now, if the username did exist, we need to, again, download and import that encrypted wallet and then decrypt it using the password and then use that wallet to connect to our smart wallet. So over here, we'll set the status callback for this one to username exist connecting to wallet. We'll then get our contract, and we'll get this by awaiting our stk.getContract, and we're going to get our smart wallet address. We're then going to need to get the metadata of that contract, which is we're going to await our contract.metadata.get. Once we have the metadata, we can get the encrypted wallet from that metadata. So we can do encrypted wallet, which is going to equal our metadata.encrypted wallet. Now, if there is no encrypted wallet in that metadata, we'll just throw an error saying there was no encrypted wallet found. But if there is, we'll set the status callback to decrypting wallet. And to decrypt our wallet, we are going to set a new promise here of just a small delay. So we'll just set a small delay here of 3 seconds, and we'll await our personal wallet, and we'll import that. And we set the encrypted JSON here to our encrypted wallet. And we're going to set the password to, again, the password that the user provides within the login. And that should decrypt the wallet. And once we have the wallet decrypted, we can use that local wallet as our EOA to then connect to our smart wallet. So we'll set the status callback to, connecting to smart wallet. And we'll await our smart wallet and connect to it using our personal wallet. Then we'll return our smart wallet there. And that there does it for our connect function. So similar to what we did before, we had to create a personal wallet, then connect our smart wallet using the personal wallet that we created. In the previous section, we used embedded wallets. In this section, we're using local wallets, but we're also doing a little customization where we are either creating a local wallet and uploading it to IPFS for a new account, or we're downloading and importing a local wallet from IPFS and using that to connect to our smart wallet. So now that we have our function set, we can head back to the login.tsx file here, and we can create our connect function here for our button. So we'll first check if there is no username or password. We'll just return out of the function because we won't be able to sign in without that. We'll then just run a try catch here. For our error, we'll set is loading to false. We'll also just console log our error. And then we'll also set error to our error message. And in our try here, we'll set is loading to true. We'll then get our wallet. We'll then create a variable for our wallet, and we will await our connect to smart wallet function, which is going to take our username, our password, and we'll set the status of string to set our loading status. So again, whatever our callbacks are, we will set the loading status to that. Then we're going to create a variable for our signer, and that is going to await our wallet, and we're going to get our signer from our wallet. We'll then set our signer to that signer, and we'll set is loading to false after all of that is complete. So again, this is going to set our loading state, and we'll be able to follow the callbacks in our loading status. It's going to run our connect wallet function using the username and password, and depending on what flow we need to take, we'll be able to connect to our smart wallet. Once our wallet's connected, we're going to get the signer of that wallet and set the signer to our state variable. We're going to use that signer to get an instance of our SDK in our connected state, so then a user can then use our application. So what that means is next we're going to create this component right here for when we are connected to our wallet. So I'm going to create a new component or a new file in our component called connected.tsx. And in this connected.tsx file, we're going to export a connected component. And using the username and signer here, we have our username, which is going to be a string, and our signer is going to be of type signer from ethers. And for this connected state, we are going to return a thirdweb SDK provider. And then we'll create our connected inner component here. And that connected inner component is going to take our username. We don't need the signer here. Our thirdweb SDK provider, though, will take our signer. We'll also set the active chain to chain from our constants. And we'll set our client ID to our thirdweb API key that we also stored in our constants. And then we'll create our connected inner here. So again, this is for when our wallet is connected to our application. We'll create our component in here. So for when so if we take a look at our demo app of our previous one, when we do sign in, we are going to just show the username. We'll show the wallet address, and then we'll show some options to demo out claiming an NFT and everything with here, and seeing that we can still pull the owned NFTs from that wallet address. So coming back to our code editor here, I'm going to get the address of the connected wallet using the use address hook. I'm also going to just create a quick function here to truncate that address. We're going to get the contract of our NFT that we're going to be able to claim. And then to do that, we can use the use contract hook and get it with our NFT collection. Then we're going to get the owned NFTs. So we'll just get owned NFTs here. Owned NFTs. We'll check is loading. And we're going to use the use owned NFTs hook with the contract and the address of the connected wallet. So for our component that we're going to be displaying, we're going to create a div here with the class name of styles. Oh, let's import styles. .card. And if we do have an address connected, We're going to display a div here with our connected header. It's going to say welcome, and it's going to show the username of the user that signed in. And then we'll just show a small truncated version of the smart wallet address. And then below that, we'll just create a div with the styles of connected claim. It'll have a Web3 button to claim an NFT. We'll set the contract address to our NFT collection, and the action will be, the collection is in ERC4337. So we're going to call the claim function. We'll put the token ID of token ID 0, and we're going to be claiming 1 NFT. And then once we have our owned NFTs here, we're going to check if the length is greater than 0. If not, it means we don't own any NFTs. If it is greater than 0, we're going to get the quantity of token ID 0 and then display that with the quantity owned. And with that, we can come back to our application, which is this one right here. Oh, we hit login, but we didn't set our login. Let's go back to our code editor here real quick. In our login here, we have to set our connected here. We're going to set this here to username and signer. We're also going to come to our index.tsx here. And in here, we're going to put in our login component. And our login component is going to take our is open and our on close. So there you go. We'll just come back here again. We have our login. So we hit login. We can put in a username and a password. So again, once we hit login, we'll go through that custom connect flow, checking if our username exists. It is a new user, so it's going to generate a new wallet. It's uploading this wallet and registering that uploaded metadata URI to our username on our custom account factory contract. This process in the connect flow does take some time because it is one, uploading the metadata to IPFS, and then it is also making sure that we run the register function on our account contract to register the username to that metadata IPFS. And there you go. You can see we have connected. We have our username here. We have our wallet address, and we have no NFTs because it's a new account that we created, but we can hit claim NFT. Again, local wallet is signless. We do have gasless enabled on our smart wallets. So we can, again, not have to interact or sign transactions or have a pop-up showing gas fees that we need to pay. We can just hit claim NFT here. Once that goes through, you can see we now have a quantity of 1. And there you go. We built our very own custom account factory contract, built a very unique custom connect flow where a user can sign in with a username and password. And now again, the user experience is very familiar where a user signs in with a username and password. But what we're doing on the back end and what we're doing with smart wallets and account abstraction is this unique flow of using a combination of smart wallets and local wallets and being able to upload the encrypted JSON wallet of the local wallet to IPFS and having the ability to download it and decrypt it and use it on any device that the user may be logging in from. And there you have it. That does it for our creating your own very custom account factory contract and custom connect flow in this course. And that does it for our account abstraction course. I hope you learned a lot about account abstraction and you learned how you can easily implement account abstraction or smart wallets into your Web3 applications using thirdweb's tools. Now we covered a lot in this course, from going over what is account abstraction to how account abstraction works and some of the use cases and whys behind why you might want to use account abstraction in your Web3 application. In the following sections, we covered account factory contracts and the account factory contracts thirdweb has to offer. We also covered how to easily implement smart wallets into your Web3 application using thirdweb's Connect Wallet UI component. We then did a couple projects, one creating a custom connect flow utilizing embedded wallets and smart wallets, and how we could create a flow where a user could sign in with an email, which would then generate them a wallet and use that wallet to then connect to a smart wallet. And we built our own custom UI flow and didn't use the Connect Wallet UI component. And finally, in the last section, in the final section of this course, we created our very own custom account factory contract and a custom connect flow, where a user could sign in with a username and password, and with our custom account factory contract, we could register their username to an encrypted local wallet, which we had uploaded to IPFS. And depending on whether the user existed or not, we went through a custom connect flow that we went over in the last section. So I hope you folks enjoyed this account abstraction course. I hope you learned a lot about what account abstraction is and how you can implement it into your Web3 projects. But again, all the timestamps to everything are down below in the description, along with the links to any documentation or GitHub repos that you may have encountered throughout this course. But again, I hope you folks enjoyed this video. If you did, don't forget to give it a thumbs up, hit that subscribe button, and don't forget to turn on your notification bell so you don't miss out on more course videos and our tutorial videos that we post on our YouTube channel. If you have any questions, we'll also drop down below a support link. You can check it out, open a support ticket, and our support team will be happy to help you out. But again, I hope you folks enjoyed this video, and until next time, see ya.